Hello everybody and welcome to the live stream today. It would be great to get some confirmation from my viewers that you can see me and hear me and that everything is working. I'm also going to change some settings here so that I can get a notification when you guys send me a message in the chat. Let's see that. Hello. Yep, everything works fine. Thank you very much, Paul Aesthetical. Welcome to the stream. Hello, everybody. So, we are here today for another KTANE module development live stream. As you can see on the website here that I have open, I have something highlighted in red from the last time I played the game. And that something is the rule seed tab. It is currently set to 41, but it could be any number. And one of the modules we had on the bomb when I was playing in Rule Seed 41 was 3D Maze. And I thought that should be a prime candidate for Rule Seed support. So I contacted the author Spare Wizard, and the answer I received was, go right ahead. So that's what we're gonna do today. Here is, by the way, a part of the logging, as you can see, while I was testing that the module works in Unity. I made a mistake and walked into a wrong wall, but that's not a big issue now. So here's the module. And the first thing, the very first thing that I'm going to do is I'm going to clean out some of the unused files in the assets tree. This is a bit of a preparatory work, I guess. So I know that it uses the puzzle background texture, and it uses the keypad texture. I've already determined that it uses those. So I'm going to put those in a folder called textures. I'm just going to reuse that folder. I don't think that we need either of these, but here is a little trick that I want to show to you. So I've got the Git repository open here. As you can see, I've already deleted a few files that I know won't be used. What I can do is I can stage all of these, and now I can safely delete literally anything. So let me just delete this entire folder, and you'll see that the look of the module changes. That's how I can tell that one of those textures was in use. So I can just go back to source tree, select the files that I assume were used, and revert them, and immediately they're back. So it seems that the other files that I removed were not actually used. All of this still looks good. So I'm going to move that texture folder to, like, you know, somewhere. Oh, I see, there is already a textures folder, that's why. I see, that makes sense. Of course, the the arrows on the buttons, the letters A, B, C, D, E, H, N, S, and W, and the unknown letter shape, which is what you see when you look at it in a distance. That is pretty cool. Alright, so we're gonna move those two textures in here and delete that. Models. Now, I don't think we need any of these models. We probably don't need any of these materials. That looks good. And out of these, I'm pretty sure we only need the highlight and the puzzle background, but maybe the keypad as well. So I'm going to press stage all now, because right now it seems fine. And I'm going to delete this, and it turns out the keys disappear. So that means that those keys use this model. So I will need that. So I most definitely don't... Oh, there is a second background. Let's see if that is the one that it uses. It does not. So I can safely get rid of that. It doesn't use the needy background. So these are the three that we'll need. And of course, they are going to have some material. So let's see which ones of these we can safely remove. Obviously the LEDs can go away. The needy textures can go away, materials rather. Let's see what happens with this one, right? Let's stage all of this and delete this. That seems to have made no impact, but that one does. Okay, so we do need this one. Please restore both of those files. Thank you, and there we go, we're back. Alright, so is there already a materials folder? Yes, there is. I see. There are materials for each of the letters, for each of the types of wall. This is pretty cool. And so I'm just going to move those right in here, delete that folder, and then move these into models. It turns out we don't actually have a models folder. We have modules. That one does not contain models. Alright, what models does this actually use? Let's see. We obviously have the buttons and the background, but let's see what models I use to create the screen, or the terminal as they call it. Okay, it's just a standard cube. That is pretty cool how that is constructed out of just cubes. Oh, I see. There is a separate texture on top to create this. That is very clever. I always thought that was part of the texture. That is really cool. See, they overlay a sort of semi-transparent image to give it this sort of look and feel of old adventure games. I love that. That's very clever. So let us, hello Andrea, welcome to the stream. Let me move that there. Hello everybody, welcome to the stream. Okay, so these just use normal cubes and quads, so we don't need any other models. Right, that's cube, that's quad, yeah, okay. So I'm just going to move these into the models folder, delete that extra components folder, and then move it out. There you go. Now what's in prefabs, I wonder? I see, each of these is a separate prefab. I'm going to have to investigate this later, how that is used. We can delete the example scene because we've got our scene here. This module doesn't use any fonts, so we can get rid of that. And it also doesn't use any animations, so let's get rid of that. Alright, so we can stage all of those removals of files. Now you may wonder why I kept the shaders folder up here instead of literally just moving it down here. Well, I am planning, you know what, in fact, I'm just going to delete these and show you what, show you what I'm about to do. So the thing is, several parts of this tree, obviously, such as the test harness, are part of the KTANE modkit. And the KTANE modkit occasionally gets updated, so in order to keep all of my modules up to date with the modkit, I use directory junctions. So I'm going to do the same thing here. I'm just going to run this batch file, which I have in my blank module template folder, and then Unity will immediately recalculate and re-import all of these things. Because what happened now, let me actually show you this, right? If I press dir now, you will notice that instead of having an actual build folder, it's a junction pointing into my mods folder. The same is true of project settings, and if I go inside of assets, you see that we also have a shaders folder here. So the reason I was confident in deleting that shaders folder is because the new shaders folder is going to contain the exact same shaders, and it's just going to pick up on those. And as you can see, it returned back into working order. So now I'm pretty confident that if I run this, I can probably play 3D Maze on the new test harness. There we go. I didn't actually show you this. Before I did this, the test harness was still in the old version where you can only see the module itself. But now we have the new test harness where you can see the entire BOM. Alright, next I think I'm going to show you what this module is like how do you actually solve this module. Let's take a quick look at the 3D Maze manual. There is actually a embellished version, so I guess I'm gonna show you the original first. So the first thing to do is to calculate a starting position, which consists of a row and column. We can see that the serial number, the first digit, is a 9. And the unlit indicators, let's see what unlit indicators we have. There is an unlit FRK. You know, I could totally just look at the edge work on the BOM, obviously. There's your unlit FRK. So FRK does have a letter in common with Maze Gamer, namely the Romeo. So we do need to add 1, so the 9 turns into a 10, and then we subtract 8 to get 2. So the row is 2. The last digit in the serial number is a 4, and do we have any lit indicators? I don't think we have any other indicators at all, so that's a no. So the column is literally just the last digit, which is a 4. So the column is 4. Now the next thing is we need to figure out which maze we're in. Now I've already walked around the maze a little, and you can see that there are these floor markings. Here we have the letter Bravo and Charlie, and over here we also had the letter Hotel. And we also have a letter November. Let's see what's up with that. So you will see that some of these mazes contain Alpha Bravo Charlie Delta and Hotel, but none of them contain a November. Well, okay, so this one has Bravo, Charlie, and Hotel. Let's see which one that is. It turns out it's this one here, Bravo, Charlie, Hotel. Alright, so I need to figure out where I am. Well, let's take a look at this entire line of things. We have Hotel. Let's ignore the November, so let's pretend this is blank. So we have 2 blank spaces after the Hotel, then a Charlie, blank, blank, Bravo. So we have Hotel, 2 blanks, Charlie, 2 blanks, Bravo. Let's see if I can find that anywhere in this maze. It turns out that down here, going from this Hotel down to the Charlie, down to the Bravo, that seems to fit the criterion, which means that I can now navigate up towards the Charlie, and then one further, then turn to the left. And now you will notice that here, where in the maze we have an asterisk, the actual module has a W. So this is a cardinal direction, which means that the N that we saw, which stands for north obviously, was a red herring. We needed to ignore that. So this is the real one that we need to use. Now let's go back to our row 2 and column 4, which means here, this is the location that the coordinates point to, and west of that we have this wall. Now this is quite fortuitous, we happen to be pretty close to that wall. I just need to turn right, forward, left, and then as soon as I walk into the wall, that module is solved. Now, what are we here for? What am I trying to do? Well, you see, all of these mazes are hard-coded, which means they never change. So we're going to add what is known as rule seed support, which means that users can randomize the rules of the modules, and then all they need to make sure is that the manual and the module use the same rule seed, and if they do, the rules will match up, and that way you get an infinite variety of mazes. But 3D Maze doesn't have that yet, so we're going to add that. So, I'm going to dive right in. Actually, before I dive right in, let me just quickly check if I'm done with all of this. We have the scripts, materials, models, modules. Well, since this mod is going to contain only a single module, I think I'm going to move this around. I'm going to move this into prefabs, because it is a prefab, and this into scripts. We don't need KM-BOM info extensions anymore, because that's up here now. So we can get rid of that. And I guess we'll just move that into here. And yes, I am aware that the compiler is complaining. Let's take a look at the... Oh, I have Souvenir open. Let's go back to 3D Maze. Here we go. Now, if I compile this, we get a few error messages. We have this here, get serial number. Now, the reason that is the case is because we now have a new namespace for the KM-BOM info extension. So just put the using up there, sort that, and it's done. Now let's see, well, what is this? There is forced solved, and there's also is complete apparently. Let's see where this is used. This is set to true at one point, but never actually used. Like this value is never used. So I think I'm just gonna go right ahead and remove that. Is complete. That is also only set to true and never read, but there is a chance that Souvenir is relying on this is complete. Let me quickly check that, because I happen to have Souvenir open earlier, so I can easily just go here, and indeed it checks the is complete field. So let's go straight back. So is complete needs to stay, and I'm going to mark that with a comment to remind future developers that this is for Souvenir. Okay. What are these? Code left, code right, and code straight. Okay. So these are used to identify the actual buttons. Okay, that makes sense. So handle press will know which button was pressed. Okay. Yeah. I guess I'm going to leave this code as it is, because it's perfectly fine. I'm just going to change these declarations to be constants, because I'm pretty sure that those values never change. And there we go, the compiler doesn't complain, so this is fine. Alright, now let's do something actually impactful. Let's begin by adding a new component to the module, which is the KM rule seedable component. Apply that and save that. Let's add a KM rule seedable field, and then right here, that field will probably appear in the list. There we go, and we can just drag the module in there. Okay. Now, what are all these? BLE probably stands for bottom left, oh, back left, I see. Back left east, back left west. Okay, these are parts of the wall. Oh, I see, W stands for wall and E stands for empty. That's, yeah. Okay. So each of these is probably shown or hidden in order to reveal. Ah, that is really clever. That way you don't really need to render. You know, you just enable and disable the right objects, and it shows up fine. This is really cool. Okay, so we have the letter far thing, and border. What is border? Okay, that's a gray border. It's literally what it says on the tin. Okay. Now let me see how the mazes are represented. I do have some memory of this because I remember writing the logging code for this. It looks like these are called maps, and okay, we do have some arrays here. We have 3 arrays, so each maze has 3 arrays. This is the ABC maze. It has an array for the labels, an array for the north walls, like which cells have a wall to their north, and which ones have a wall to their west. And then obviously you have the same thing for each of the mazes. And I do seem to recall that I see. So this is in the constructor for map. So when the module is initialized, it will send in the coordinates that you calculate from the serial number, and presumably the... I'm a bit surprised that there is no cardinal direct... Oh, of course, the cardinal direction is decided upon here. Ah, okay. So let me see what call message is. Okay, that is just used for a log message. So presumably when I instantiate this map, let's take a look at this. Aha, so here it's just empty. Oh, because the verifier controller. I'm not quite sure what that is. It sounds like something that the module itself doesn't use, but was intended for testing during development, and it might not be required anymore. So let's see where this is called. This is only called once. And, okay, so call MSG. Okay. So this starts out with the last digit, and then every time it is modified, it says, okay, so we have an indicator that shares a letter with help I'm lost. And if there are none, then there's no indicators. Okay, so all that is literally just a log message. So we've pretty much already covered that. Now, map index. Okay, that's just which of the maps, and then of course the module ID. That is again only used for logging. Okay. So what we need to do is we need to pass in a random number generator, which comes from the KM rule seedable component, and have this code automatically generate the maze. How do we do that? Okay. So let me quickly summarize the plan. Now, I'm going to use Inkscape to explain the algorithm that I'm going to do. I've explained this algorithm before, but in a circumstance where it was a little more advanced. So now we have a nice and simple maze generation algorithm. So imagine we have all of these cells that a maze consists of. Let's make this like 5 pixels might be a bit much. I think 1 pixel is way enough. Let's have no dashed lines, maybe 0.5 pixels. There you go. And this is a 6 by 6 maze, right? Okay, let's change that by... There you go. Okay, maybe 20. There we go. Okay, 1, 2, 3, 4, 5, 6. Alright, I'm gonna pretend it's a 5 by 5 because that happens to be my size right now. Okay, so here is how the algorithm that I'm about to implement will work. The first thing that I need to do is decide on a random cell where we're going to start. So I'm just going to randomly start at the cell here. I'm just going to make that green. Alright, now pick a random cell that is green. Alright, that's only one because, we've only marked one so far. So that's the one that we choose. Now pick one of the walls on each of the four sides. Right, let's pick the one. Okay, so I just randomly realized that I will need to be able to remove walls in order to explain this algorithm. So I'm going to draw these walls separately, and that will not take very long. I will just give that a stroke. There you go, half a pixel. Put that here, 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 here. And then also this. Here, 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 here. And now I realize that these... I need individual segments that I can remove. That was a bit hasty of me. I should have thought about this properly. Okay, so let's get rid of that. 1, 2, 3, 4, 5, 6. Well, 5 actually. There you go. And then let's do this. Put 5 walls here. Okay, so finally I have a skeleton with which I can explain the algorithm. Okay, so pick a random green square. That's this one. Right, now pick a random wall that is on any of the edges of that square. Right, let's pick this one here, just at random. So I'm going to remove that wall, in other words, make that traversable. And then the cell that I went to, I'm going to make green as well. So let's just mark that as the same shade of green. So, keep going. Next step. Choose any random green square. Now we have 2 to choose from. So hypothetically, if I choose this one again, if I now choose a random wall around this square, there are only 3 walls available. Same is true here. There's only 3 walls available because, the wall that we came from has already been removed. Alright, so let's pick this wall here at random and mark that one green. And then we do that again. Pick a random green square. Let's say we pick this one again. Now we have only 2 walls to choose from. Let's say we choose this one, alright? And then again, pick one at random. Let's say we pick this one. Pick a wall at random. Let's say we pick this one. This becomes green. Alright, now pick another square at random. Let's say we pick this one again. Pick a wall at random. Well, at this point, we have only one wall to choose from. So this is obviously the one that we're going to do. And now we have this case where we have a wall between 2 green squares. So, alright. So next, pick a green square, any green square. Let's say we pick this one. And then, now I said pick any random wall, but you see there is one wall here that at this point, we don't want to remove. At this point, we don't want to create loops. I'm going to create loops later. I'll get to that in a second. So for now, we're going to create a maze without loops. So what I'm going to do here is instead of just picking any random wall that is still open, I put a condition on it. Pick a random wall that takes you to a blue square. In other words, a square that we haven't visited yet. Do not pick any walls that go to a green square. Right? So, we pick this one at random, and that becomes green. Again, pick any green square at random. Let's say we pick this one. Pick any random wall. Now, what do? It doesn't have any walls. Well, it seems that we're done with this square, right? This square will never need to be considered again. So what I'm actually going to do now is I'm just going to mark that orange or something to say that we're completely done with that. And the only purpose of that is so that in the next step, when I now say pick any random green square, it will not pick that because it's not green anymore. And that's basically it, right? So we just keep doing this. Pick a random green square, pick a random wall, go there. And we keep doing this until we run out of blue squares. Now there is one thing that is relatively unique about 3D Maze compared to most other maze modules, which is that you don't actually have walls all around the edges. You can actually wrap around. The entire maze is toroidal, is the technical term in geometry. So, I'm going to allow the algorithm to do that as well. So if you were to pick this green square and you want to pick the wall that goes up, then that's fine. You remove that wall, which is also this wall here, and make that square green. So that can work too. So at the end of this, we will end up with a maze. I'm going to finish this, and or maybe not. It's a bit... I don't really need to finish this. So let's say we have this maze now. So I said earlier that I want to create a maze with no loops, but obviously there are tons of loops in these mazes. In fact, these mazes are pretty, how shall I say, loose, sparse, whatever you want to call it. Now, obviously, these were hand-designed, handcrafted. The algorithm is not going to, create the sort of nice beauty of this. But what we can do is once we're done with our maze, we can literally just remove half of the walls at random. And that will leave us with a number of walls which will hopefully match approximately the number of walls that we have here. In fact, I've been meaning to find out exactly what ratio of walls we should be removing. So let's count how many walls there are in a typical maze. Like I'm just randomly going to pick the ACH maze. And if I'm just going to change all the ones to any other character, we see there are 45 walls in this maze. Right, now how many possible walls could there be in this maze? Well, it's actually an 8x8 maze, so that's 64 cells. Each cell can have a north or a west wall, so that's 128 possible walls. And how many did we say we had? I've already forgotten. It was 45, that's right. So 45 out of 128 would be about 35%. However, we're already running a maze generation algorithm first, which means that we won't actually start with all of the mazes. Now, how many walls have we already removed after the running of this algorithm? Well, it turns out it's not actually that hard to estimate, because every time that we pick a random cell, we remove one wall and mark one more square green. So the number of walls that we remove is exactly equal to the number of squares in the grid minus the starting square, but that one square doesn't matter because we're estimating anyway. So we'll actually be removing exactly 64 cells because it's 64 walls because it's 64 cells in the entire grid, 8x8. So we will end up with let's see. So there are 128 in total, and we've removed 64, which means that's exactly half of them. So we would be left with 64 cells, but the maze that we just looked at only has 45 cells. So we actually want to keep about 70% of the walls at random. So we're going to remove 30% of the walls, and that's it. Now let's see what you guys have to say about this. Hello, Mark Sam. If any of you have any questions about this, of course, I'm happy to explain. But for now, I'm going to dive right in and start writing the code. So I'm going to add a parameter here, which is monorandom RND. So that will be the random number generator. Let me quickly make sure I understand what's up with the other constructor, because there is a second constructor here which calls this constructor. Oh, I see. It's the exact same thing, but with the map index. I see. So does anything... Right, okay, so let me add the monorandom RND here. Add it here. And now let me see if anything else calls this constructor. Yes, it turns out this one does. No, this is the constructor without the... Ah, okay. It misidentified this because I haven't added the monorandom thing yet. Okay, and this one also doesn't have... Oh, this one does have the map index because, this is from the verifier controller. Now, I don't know what the verifier controller... I don't know how to use it. I am going to just delete it and see if the module still works without it. And if that is the case... Because the test harness is way enough to, to test things. So I don't think we need another way to test things. Yeah, so I'm going to delete those two files. Andrio says, I've made a few more changes on Souvenir, don't forget to pull those. Okay, I will do that if I'm going to work on Souvenir. Right, there is apparently... okay, that's the constructor that I changed. Okay. So the compiler is not complaining about any of the removed verifier controller things. So I'm just gonna live without those. And that means that I don't need this constructor anymore. So I'm actually going to use this constructor entirely. Like that. Okay. And the map index will now be decided on at random. The map index is going to be Unity Engine dot random dot range 0 10. Okay, var. Okay. Now this, of course, is part of the. Okay, so I'm trying. So we're gonna have two pieces of logic going on here. We're gonna have the maze generator, which depends only on the rule seed, and then we're gonna have the thing that decides on the cardinal directions and calculates the start and end position. That one depends on the Unity engine random number generator and the edge work. I think I'm going to let's think about this a little more. In fact, let me see what other stuff is in this map class. There is a map node object. All right. Map itself has. There we go. It has a width. These are okay. These are the winning squares, the x and y coordinates of the winning squares, because the wall spans 2 squares, so that makes sense. Oh, I see. The map class also takes care of the player position. That's very interesting. So that should mean then that this module here, the 3D maze thing, 3D maze module itself, probably contains relatively little code. Okay, so this checks whether the the indicators contain any letters in common with something, and then this is the button press handler. This updates, this updates the layered, okay, this is pretty cool. Okay, so that means that all of the logic that I'm about to implement should all go into the map class. Now I'm going to just put the random, the rule seed code in the middle of where it would go. So here we are going to say if the rule seed is equal to 1, then we're going to use the same maps that we've always used, like this. And in all other cases, we are going to generate our own maps. Okay, so we're going to start with a maze generation. Okay, so here's another thing, right? So we have this north walls and west walls thing, but it turns out that there is this piece of code here which goes through it and creates these map node objects. So I'm thinking you could actually just generate those map nodes directly. So I think I'm going to put all of this code inside of this if as well. There we go. Okay, now the compiler complains about labels. Alright, did I put the declaration for label? Okay, it's because it's unassigned, not because it's not known. That makes sense, because I only assign it when the rule seed is equal to 1. So, inside the else clause, which is here, where rule seed starts here, or rule seeded code, let's call it that. So here I'm going to have to set the labels array, the end direction. Okay, it decides on the end direction here and the decoy direction. Okay, so this is a clever way to generate two random numbers that are different from one another. Just reduce the end bound here, and then if it's greater or equal to the other one, just increment it. So I think I'm just going to move this to the beginning of this method, to above the rule seeded code. Then again, wait, why do I want it above the rule seeded code? It's because, okay, so something is changed here. Okay, so this code tries to modify the labels, okay, so the maps have these asterisks in them, which are also shown in the manual right here. So it wants to set those to the direction, the cardinal, like north, south, east, west, that the module decided is going to be the actual, solution direction, as opposed to the decoy. So let me think about how to do this. I think I'm going to change map node in such a way that the label, well, let me find out where it places the decoys. Ah, it says here add 3 decoys. Okay. Let me think about this. Okay, so we will end up with this map data 2-dimensional array. Hello, Livio. We will end up with this map data 2-dimensional array which contains these classes, and inside these classes I can still change the yeah, okay, so this is what I'm gonna do. I'm just not going to change the label here. I'm going to have map data contain the asterisks, and then later I'm going to change them outside of the rule-seeded code. Okay. Specifically, I'm going to... Aha, see, this code already does that. It literally just assigns label here. So replace the asterisks in the map with the true cardinal at 3 decoy cardinal. Cardinal direct. I should call it cardinal direction. So, so for each... okay, so for each x coordinate from 0 to 8 and for each y coordinate from 0 to 8, if the label at that position, so we want map data of xy.label, if that is equal to an asterisk, then we set it to this. Direction to character, yeah, that one just gives us the character. Okay. So now this cleanly happens outside of the rule-seeded code. That is good. So we can generate the maze using these map node objects and have them have asterisks in the labels. Yeah, let's do that. Okay. So let's get going with the actual algorithm, I guess. I do apologize if I sometimes sort of stop and think, but there are a few, like for example, still complaints about this. Ah, selected map. So let's see, label select many. Where? Now labels was, let's see, it's a string array. Oh, I see. Oh, I already said this. This is just unassigned. It's not that it doesn't know about the variable, it's just that it hasn't been assigned, and the rule-seeded code is going to assign that. So let's see what I need to put in there. Ah, okay, it's an array of strings. Okay, got it. Are you actually alive? I'm not quite... Oh, Spare Wizard. Spare Wizard is here! Welcome to the stream, Spare Wizard. So far, I've basically only looked at your code, and I've explained the algorithm that I'm about to implement. And now I'm going to start implementing it. Let's go. You know, honestly, this here bothers me a little. I'm just quickly going to change this. The n wall is true whenever this is equal to 1. So we can literally just write it like this, and then this entire block here can be reduced. So if that is 1, that is true. Okay, and now we can easily see that we can actually just inline all of these. So we can just put all of these conditions right in there, and then reduce the size of this for loop. Hello, Spare Wizard. Yeah, okay, we've seen you. Okay, okay, so now all that this non-rule-seeded code does is literally just put something into these arrays, labels, n walls, and w walls, and then generate the map node objects from it. So that's what I want the rule-seeded code to do as well. Ah, okay, so what this is actually trying to do is just list the 3 letters. You know, it's, for example, CDH. I didn't realize that, but there we go, that's what it does. I don't blame you because my first module's code is very... I wasn't saying that any of this code is bad. I was just suggesting some potential improvements. So, alright, we're now going to start the actual algorithm. So we're going to have an array of... we're going to have a collection of cells. So let's see. So each map node. Ah, the map nodes don't actually have coordinates on them. which is fine, of course. But let's see if okay. So if you don't mind, I'm going to move this map node class to a separate file, so that each type is in a file by itself. So I'm just going to move this to here, and I'm going to create another one. Actually, let me remove the usings. That is not what I meant to open. I meant to open this, remove the usings. And then let me create another class which will literally just contain an x and a y coordinate. So I'm going to make that a struct. I'm going to call it coordinate because y plural, thank you. And it's going to have a public int x and a public int y. Okay, let's, I think I do want these to be in a namespace. So I'm going to put all of this into a namespace. Let's put that in a namespace, there we go. Let's also say this is sealed, because that doesn't need subclassing. This can also be sealed. I don't think that needs to be public. There we go. So we can close these now. And then map itself, of course, also goes in a namespace. Okay. So here we are now going to, let's expand that. We're going to say using 3D maze, and then all of that will work. Okay, so now let's actually get started with this. I've been faffing around for long enough. Oh, why is this inconsistent accessibility? The return type map view is less accessible than the method. Okay, that's because this is public. That doesn't need to be public. However, I'm going to make it sealed because we don't need to subclass that either. Let's see. Okay, so this one is going to, yeah, so I can just say rule seedable get RNG right here to appease that. And then we have this. Okay. So I think this one does need to be public. So in that case, I'm just going to make all of it public. If that's how it's going to. Wait, hang on. Actually, yeah. Why does this? Why is it even protected? This class is not going to get subclassed, so that doesn't need to be protected at all. So let's remove the public again, and now the compiler should be happy. Okay, so this is the only thing left. All right, now we can finally start. Okay, we are going to have a collection of all of the squares. So they all start out blue in my example coloring here. So I'm just going to say all the blue ones are going to be, let's see, we want all of the numbers from 0 to 64. And then for each of these indexes, we're going to create a coordinates thing where the x-coordinate is modulo 8 and the y-coordinate is divided by 8. And that way we get all of them. And we're going to put that in a list. Okay, so these are the blue ones. Now the ones that we've already visited are the green ones. So we're going to make that a new list of coordinates which is initially empty. And then of course we have the yellow ones which are done. Okay, now obviously blue, green, yellow are excessively bad variable names for these because that relies on my particular visualization of this algorithm. So I'm going to give these proper names. What are the blue ones? The blue ones are the ones that we haven't visited yet, so we still need to do them. The green ones are the ones that we visited, so I'm going to call that visited. And the yellow ones are done. Okay, now while there is stuff left to do, see this code almost writes itself, pick a random cell that we want. Right, so we have a cell index, so let's use the random number generator to get an index from 0 to the length of this. And then the actual cell is going to be that, and then we want to remove that from the list. And now we want to create a list of the valid walls that we can traverse from this cell. So let's see, var valid walls is a new list. Okay, so how do I represent a wall? I think I'm going to use coordinate for this as well, and I'm gonna put in the coordinate of the cell on the other side, which may or may not be on the other side of the maze, because it may or may not wrap around the entire map. Okay? No, actually, oh, I have another idea. The valid walls are the ones, you know, I can use cardinal directions for this, so I'm actually just going to use integers, and we already have these constant declarations here that we can use, north, east, south, and west. So this is what I'm going to do. Okay, so if the cell that, so first of all, yeah, that's right, we want to find a cell that is one cell away, which is blue. And the blue ones are in to-do. So if the cell above us right now is in to-do, so if to-do.any, if any of those coordinates has the same x-coordinate as the one we're looking at, and the y-coordinate is 1 above, so that would be the y-coordinate of our current cell minus 1. So if that is the case, then we can say that north is a valid wall. Now there is a problem with this code, because cell.y could be 0, and we don't want this to be negative. We need it to wrap around. So instead of minus 1, I'm actually going to add 7, which will, you know, I'm going to add 7 and then modulo 8, and because under modulo 8, plus 7 is the same as minus 1, except that it always remains positive. So this is one way to do that. Okay, now obviously for the south wall, we're just going to add 1. For the west wall, we're going to do the same as what we did with the y-coordinate, but this time with the x-coordinate. So this will just be cell.y, but this will be that, except this is east because we're going to the right, and then west is the one where we go plus 7. Okay, now let me put them in the same order that the constants are defined. Alright, now we have a list of valid walls. Now there are two things that can happen. Either there aren't any valid walls, or there are. Well, if there aren't any, then we want to move this, you know, we're now marking this yellow because we're done with all the walls around it. So what we're going to do is we're going to add this to the done list, add the cell to the done list, and remove it from, we've already removed it from to do. So it just occurred to me that what I actually want to choose from is not at all the to-do list. I want to choose a random green cell, not a blue cell. So I actually need to choose at random from the visited list. But I do need to find a wall that takes me to a blue square. There we go. Now the visited list starts out empty, but you know, I need to choose a random square to start from. So the start index is going to be a random value from 0 to the number of things that are in to-do. And I'm going to put the coordinate into the visited array and then remove it from the to-do array at the same index. Okay. And now generate a maze. So let's see. Okay, so we've chosen a random green cell. What's your algorithm for maze generation? The existing maps have many cycles, walls of varying length. I suppose you weren't here for my explanation. So what I am going to do is I'm going to generate a standard maze, which is not going to have any loops at first, and then I'm going to remove exactly 30% of the walls at random. And why 30%? It's because I calculated that the number of walls that are missing in one of your mazes is 69%, which is close enough to 70%. So I'm just going to remove 30% of the walls. I suppose actually I could generate a random number between 25 and 35% or something like that. Alright, so that's what I'm going to do. But first I'm going to generate a standard tight maze. So let's see. Okay, so if we don't have any valid walls, then that cell is done, and we want to we've already removed it from visited, so we don't need that. Continue the while loop from here. Now, if we do have a valid wall, then we're going to have to choose one at random. So let's decide on an index, which is a value between 0 and the number of valid walls. And then the actual wall is, of course, valid walls at that index. I strongly suspect that I can probably inline that variable, but we'll see in a second. And now I want to first of all add the cell that the wall goes to. Okay, so in this code that I'm about to write, I'm going to need this logic again, the logic that takes a current cell and finds me the coordinates of the adjacent cell. So I'm going to write a function for that. Let's create a function here. Let's have a private static coordinate neighbor coordinate cell and then int direction. Right, and then depending on the direction, if it's north, we are going to return a new coordinate object where x is the same, and then y, of course, is, so we're going north, so we want to subtract 1, but we're going to go modulo 8, so I'm going to go plus 7, same as before. So we have north, east, south, and then I'm just going to say default so that the compiler doesn't complain about missing cases. Alright, so east is where we want to go plus 1 on the x coordinate. And then south is just plus 1 on this. And then here I'm just going to go plus 7 on that. Okay, so this gives me the neighbor of any cell. Right, so I can say var neighbors equals, well, we're going to have 4 cardinal directions, and for each direction, let's get me the neighbor of the current cell in that direction. That will give me an array. And now I can just say, so now I have an array of coordinates, so I can just filter this and see which of these coordinates is in to-do. To-do.contains that coordinate. There you go. And then I don't need any of this. I don't need, right, so valid walls is literally just that. Right, and then I'll just make that a length, because it's an array now. Pick a random valid wall. Okay. But now this is no longer a cardinal direction. This is now an actual cell. So I am going to say, give me both the direction, so the direction is going to be dir, and the new cell is going to be the neighbor. Okay, and then check that the to-do list contains the cell. Now, here's a little worry I have, which is that because this is a struct with 2 fields, I don't know if the equals operator works on this, so I don't know if dot contains works properly on this. So I'm going to go through the whole thing and make this I-equatable coordinate and implement that and say return other.x equals x and other.y equals y. You know, and since I'm already at it, I'm also going to implement a quick hash function, so I'm just going to go x times 37 plus y. There you go. That's some random hash function. And then while I'm at it also, I can implement the object equals function, which is true only if object is a coordinate, and coordinate obj.equals this. Well, I suppose I can write it like that. There you go. Okay, so that should be pretty simple. And you know, since I'm already going the full Monty on this, I think I'm also going to make these properties and implement a constructor which takes an x and a y coordinate and sets x to x and y to y. And the reason I want to do that is so that here, instead of having to write out x equals and y equals, I can just do this. Okay. That should be a little easier. Okay, so with that out of the way, oh yeah, the neighbor function also needs that. So I'm just going to change that to an open parenthesis, and y equals can just go away, and then the close curlies become close parentheses. Okay, and that should be correct. So, now that we've chosen a random wall which contains a direction and the cell that the wall goes to, let's see, we want to do two things. First, we want to actually remove the wall. In order to do that, we need to have our map node objects. So I'm going to start a map. Right, in fact, map data. Right, let's see. That's okay. It's already. Ooh, you actually have a width thing here. I see. I shouldn't hardcode 8. Right, you know, I used the number 8 several times in this code here. I should really use that constant that is already defined. Right, and then, ooh, I even made a mistake. Look at this. I found the mistake by fixing this. Okay, so this is better programming practice, so that whoever reads the code, when they see the number 8, they would first have to think about why is it an 8 specifically. But if it says width, it literally tells you what it is. Of course, it's the width of the map. That makes sense. Okay. Right, where were we? Ooh, okay, so map data. So map data is already assigned an array of the right size. However, each of these objects inside of it are going to be null. So we're going to have to instantiate these. And, you did actually point out the modulo 7, thank you, and I didn't see that. And I managed to fix that on my own. What is IEquatable? IEquatable is an interface that allows C# to compare two objects for equality, and I'm using that just to make absolutely sure that the .contains method will recognize two coordinate objects as the same value. Okay, so with that out of the way, I'm going to say for each x coordinate from 0 to width, for each y coordinate from 0 to width, set the map data object to, let's see, well, I guess we don't really need a label just yet. We're going to decide on the labels later or place them at random, I guess. So I'm just gonna put 0 there, I guess. False, false. You know, these are all default values. This really should have, I mean, for this purpose now, this should have a default constructor. So I'm just gonna do this. Okay, but since it does have this constructor, no. If I make these private setter, then I cannot change them later. So no, this is what I'm gonna go with. Okay. So now we have all of these map nodes. Oh, we do want to start out with with walls everywhere, because the algorithm assumes that there is a wall everywhere and then removes the walls as it goes along. So I'm actually going to have to say true there. So I'm going to remove that default constructor again, just to make that explicit. Also, the label, when there is no label, it's actually a space character. So maybe I should initialize them as spaces so I don't have to worry about that later. Okay. So now we can actually remove the wall. If I'm going to use another switch statement here, because the cardinal direction, if that cardinal direction is north, then we can literally just change the north wall of the place where we are. So we're going to say map data wall.coordinate x, comma wall.cell y dot north wall equals false. Alright, break. Now if it's west, then the same is true for the west wall. But if it's south or east, then we're going to have to modify the cell on the other side of the wall. So south is the one where you go +1, modulo width obviously. And then for the east direction, which I'm just going to say default here, we want to use the cell on the right and modulo that by see, I almost instinctively typed another 8 there. Okay, and we changed the west wall of that. Okay, so that's the first thing we do. We change the wall. The second thing we need to do is we need to mark the cell that we went to green, because it is currently blue. We specifically chose only walls that go to a blue cell, and we now want to make that blue cell green. So we're going to remove it from to do, right? So to do, remove the cell that the wall goes to, and then put it into visited. There we go. And this way, the to-do list will just keep shrinking until there is none of it left. Okay, so at the end of this, we will end up with a maze that has, a tight maze that has like a lot of walls with no loops, and also no labels. So I think I'm going to put some random labels in. Hang on, let me try and remind myself. So when I decided on the map, okay, it says random range 0, 10. I guess that makes sense. Okay. So I need to decide at this point whether I want to actually use the letters A, B, C, D, H, or whether I want to vary those as well. If I want to vary those, then I will have to design separate textures for those extra letters that I want to introduce. So I guess for now I'm not going to do that because that's a lot of work. If that is what I'm doing, then it's always going to be 10 mazes. Or even if I use different letters, it's always going to be 10 mazes, as long as there are A, B, C, D, H. So that's 5 possible letters, and there are 3 of them in a maze, so you get 5 choose 3, which is, of course, as we all know, 5 factorial divided by 3 factorial divided by 2 factorial, 10. So there are 10 possible mazes, always. Okay. So here's what I'm going to do. So instead of having the switch case, I'm going to have a list of mazes. Hello, Sean. Welcome to the stream. Okay. Yeah, okay, so this is what I'm going to do. I'm going to have a single list containing all mazes, and each entry in that is going to be a map cell. What was it called? A map node. 2-dimensional array. And I want it new in front. So this way, I will have a list of mazes, and I can literally just choose one at random. Okay, so that means that all of these yeah, there's still that thing about the but I can just go through the map nodes to get the label. Okay, so here's what I'm gonna do. I'm gonna put this in here. Okay. And then here where it says label, I'm just quickly going to fix this, right? So here I'm going to say, first I need to decide on a maze, right? So the maze that I decide on is going to be random.range 0 to 10, I guess. And then the actual maze is going to be this one at that index. Yeah, I can literally inline that. Alright, so we just choose a maze at random. Allow me to make this consistent. And now I can just say maze. Right, I can say enumerable.range 0, 64. 64 should now be width times width, I guess. Not widget. So let me just quickly see where else I used the 64. Here. So let's fix that. Anywhere else? Nope. That's where it was. Okay, so for each of these, I'm going to say dot select maze. Okay, so we have an index, and I want the index modulo width, and then the index divide by the width, dot label. This gives me all of the labels, including the spaces, of course, and we'll count only the ABCDHs. And there we go. That's our log message fixed. And now, outside of the rule seed code, we only need this mazes array, or list rather, which has map node things. So in here, instead of a switch now, I'm going to use a for loop. Well, not instead of the switch. I'm going to use a for loop to populate this mazes list. So let's go. For var map index equals 0, map index less than 10, map index plus plus. Take all of this, boink, like that. I suspected that Visual Studio wouldn't automatically indent all of these. The indentation is already wrong. Okay, fine, I will do it manually. This is going to be very annoying to do manually. Okay, I can do this. I'm sure I can do this. Wait a second, can't I just... Yeah, can't I just... this is a cool trick. I can just literally indent everything by 2 lines. Like this, and then just run the auto formatter again. There you go, and that fixed it. Oof. Right, now map index doesn't need to be decided at random here anymore. So for each of these map indexes, we're gonna do this. Now, where's map data defined? Oh, I see. Yeah, I guess that should really be a private, not, I mean, a local now. Except, okay, so I should assign this only after I've decided on the maze. So inside, so this shouldn't really assign here. This should assign at the end of the rule seed. So for now, I'm just going to rename this just to make sure that the compiler will complain about all other uses of that variable. And yes, I will fix all of those afterwards. In fact, I guess I can, I guess I can light map data. That's an interesting coincidence that there is a Unity thing called that. Okay, so for each of these map indexes, I'm going to create a new map data, which is a map node of width proportion. There you go. Right, and then this will populate those 3 variables, and then this will set all of the maze nodes, and then after that I'm going to say mazes.add map data. Okay, and so it will do that 10 times, so at the end the mazes list will contain all 10 of them. Alright, this is really cool, so this is working. And now here, when I decide on the actual maze, here, I'm going to change that to map data. Final map data, rather. Okay. So this can do that. Okay. Whereas here, I do need to use the map data for that particular rule seed, right? So I'm going to generate one here, call it new map node width. There we go. Okay. So back to the actual algorithm. So I've removed the wall. I've marked the next cell green. So when I'm done with all of this, I now want to remove 30% of the remaining walls to make the maze more spacious, I guess. Okay, so let's create a list of all of the walls. So for each x coordinate from 0 to width, and then for each y coordinate from 0 to width. Okay, so the remaining walls are going to be a list of, let's see, we're going to have an x coordinate, a y coordinate, and a, you know, whether it's north or west. How do I represent that? What's the best way to represent that? I'm going to use a trick. I'm just going to use integers for this, and here's what I'm gonna do. If maze data, which is actually no, it shouldn't. Oh, it should be map data, not maze data. My apologies. So if that has a north wall, then remaining walls.add. Now here's the thing. I'm going to encode all of that information in an integer. Right, I can go width times y plus x. This is the normal way to encode a coordinate on a rectilinear grid in a single integer. But now what I can do is I can multiply the whole thing times 2, and that will give me the extra space, you know, to have that extra 1 bit of whether it's a north wall or an east wall. Sorry, west wall. So if it has a west wall, then it's going to be +1. All right. So we want to remove 30% of the remaining walls. So the first thing that we're going to do is just shuffle the entire list. And then, actually, let's remove between... Wait, okay, I want to try something else. Because remember, I counted the number of walls in one of these mazes. What I'm going to do now is I'm going to count them in all of these mazes. Let's do that. And yeah, let's actually just count all of them and then take an average, right? So if I just replace all ones here with something, that's 500. Is that a coincidence that there happens to be 500? So that's 500 walls out of across 10 mazes. So it's an average of 50 walls, and we've decided that 64 walls will be is normal. So 78% of the walls are usually there, which means that we would, if we remove 22%, then that would be your average. So I'm gonna say a random number between 20% and 35%. How about that? 20 to 35. So remove 20 to 35%. Okay, so the percentage is going to be a value. Okay, so this is a span of 15%, so I'm going to multiply this by 0.15 and then add 0.2. So this will give me a value between 0.2 and 0.35. So we have our list of remaining walls. So all we really need to do is just truncate the list to the right amount. So I can just say remaining walls dot remove range, and I need an index and a count. So let's see, how many walls do we want to keep? Like, keep walls is going to be remaining walls dot count times the percentage, and then I want to round that down. Okay. So this is how many walls I want to keep, not how many I want to remove. So we remove everything starting at the keep walls index all the way up to count minus that. There we go. Okay. Let's put that here. Okay. So that this list is actually irrelevant. What I need to do is I need to modify the map data object. So I'm actually, instead of remove range, I'm just going to go through all indexes starting at keep walls, going all the way up to the rest of that list. Yeah, there we go. This is what I'm gonna do. And then of course the x coordinate is well, first of all, is it an east wall? It is an east wall if the number is odd, because we added 1. Alright? And then is it, so what is the x coordinate? Well, in order to get that, we need to divide by the 2 in order to remove that extra bit we added, and then go percent the width. So that is our x coordinate. The y coordinate is that divided the width, divided by the width, and then the map data at position xy. I suppose if e, then it's east wall, excuse me, west wall, obviously. Then we want to remove the west wall, else we want to remove the north wall. There you go. Okay, so this w can just go right in here, obviously. I suppose technically x and y, yeah, you know what, they can go in there as well, so just inline that, inline that. Okay. So I think I may have made a mistake, because what I just did is I kept only 20 to 35%, but I actually wanted to keep more like 78%. So actually this percentage is the amount that I want to remove. So this is actually how much I want to remove, and I'm gonna go from 0 to that. There you go. Okay, so that will remove quite a bunch of walls. Alright. Finally, we need to add the labels. So here, let's so we now have one piece of code that generates one maze, but we need to generate 10 mazes, obviously. So the labels are going to be, let's see, we have ABC, ABD, ABH, then we have ACD, ACH, then we have ADH, then we have BCD, BCH, and CDH. 1, 2, 3, 4, 5, 6, 7, 8, 9. I missed one. 5, 6, 7, 8, 9. I definitely missed one. BDH is the one I missed. Thank you, Spare Wizard. I figured it out just before you said that. Alright, so let's split that at commas, and now for each labels in maze labels, we're just going to go through all of this code, that part of the code also, and then at the end we're going to say mazes.add map data, except that now we need to put in the labels. Alright, so add, so how many instances of each label are there? I think there are 4 or 5. There are 5 of this one. It seems to be 5 always. Is it always 5? 5 of each label? Yeah, I think I'm gonna do that. Now, here's another thing, Spare Wizard. I noticed that in your mazes, you never have labels right next to each other, which makes sense, you know, as a sort of human intuitive thing. If, you know, when you're designing these mazes by hand, that is probably something that you would do. But the random number generator will not do that. It will sometimes randomly generate 2 coordinates right next to each other. I think this might not actually be an issue. And I think that, you know, because it's rule seed, and you always play with a different rule seed, I think I'm going to genuinely randomize this and not do any extra effort to have them sort of spread out or anything. Is that okay? So add the labels, 5 of each letter. So for this we're going to need 5 times 3, so 30 coordinates that don't already have a floor marking. And then of course we need an additional, how many? 1, 2, 3. Right, it seems there are always 3 asterisks. So asterisks. So okay, so that means we need 33 cells. Select 33 random cells for the labels, letters, and cardinals. It's okay for now, can be implemented later if it's a problem. I suppose. It's just, you know, if it can be avoided, I would like to try, you know, because what you're proposing is to change the rules later, and then, you know, there is a chance that 2 versions of the rule-seeded manuals are in circulation, and I want to kind of avoid that situation, so that, you know, because it would mean that people could potentially accidentally play with the wrong manual, even though they have the right rule seed. But that said, I did actually do that with Polyhedral Maze and some other modules of my own. I did change the rule seed rules sometimes. So, oh, okay, fair point. Later in development after testing. Okay, yes, you're right. In that case, then let's revisit it later. Okay, so we need 33 random cells for the labels. Okay. So the thing is, right, we still have our to do and our visited and our done. And obviously, because of this while loop, we know that to do doesn't contain anything. So visited still contains all of the green stuff, and done contains all of the yellow stuff. So I'm going to just put all of the done stuff into visited. No, the other way around, because we're done. So done.add range all of the visited ones. And that will automatically give me a list of coordinates, right? And then I can just shuffle that, and then just use the 33 first elements in there. So add the labels, 5 for each letter. So for each letter in letters, did I not call it letters? What did I call it? Ah, labels. Yep, labels. 5 times. Yeah, I need to make this a for loop because so letter index, let's call it that. There you go. Map data at this position, the position being done. Ah, okay, so I need the cell. So the cell is, let's see, I want 5 times the letter index plus I. Okay, so the maze data at that point gets its label assigned the letter, which honestly at this point I'll just inline. There you go. Okay, so we don't need those brackets. And then add the asterisks, add the 3 asterisks, there you go. So we have 3 of them, and we're just gonna say, we're gonna say varcel equals done 30 plus I, and then map data cell.x cell.y.label equals asterisk. Can I inline this? I mean, I can, but yeah, I think this is readable enough, isn't it? Inline that, whoops, just to make it smaller. Okay, so now we've added the labels, the asterisks, and I think that's it done. Now, this code here will choose a random map. All of this code probably doesn't change. So replace the asterisks with the true cardinal direction. Yeah, it will just do that. Add 3 decoy cardinal directions. Yeah, it intentionally chooses spaces with a space in them, so it doesn't clash with the asterisks or anything else. And then it chooses the player position and direction. What does this do? While not get edge. What does get edge do? Bound. Okay. You can just use modulo for that. Okay, I think I get it. Or do I? When is getEdge called with any other values? Ooh, I see. Okay, let's see if we get any comments on this. That finds the next wall in a direction. Ah, okay. Oh, I see. So what this does is it makes sure that there is no long corridor going through the entire map and therefore having no wall at all. Is that what it is? No, oh, I see. Oh, okay, now I get it. This entire while loop does what you said. It finds, right, okay, so while there is no wall there, it's for placing the solution. Ah, yeah, exactly, exactly. So this while loop finds out where the solution wall is, and then we set these values to the position of the solution wall. Got it. Yeah, so I guess I'll just leave this code. So, but that does mean that we need to make sure that the final mazes will not have any long corridors, because that will cause this while loop to I just thought of an issue. What if a maze is generated with no... Yeah, exactly. Literally what I just said. Possible to generate an unsolvable maze. Well, what we have to do is we have to make sure that that doesn't happen. So I'm going to put a try again label here. And let's see. Make sure that there are no rows and columns entirely without walls, because that can make a maze unsolvable if what do you call the coordinates that you calculate in the manual? Let's see what you call that. Goal, of course, goal. That's a very good choice of word. Yes. If the goal is in that row column. So for each x coordinate from 0 to width, if enumerable range 0 to width all So now I'm looking at a column. So if all of the y coordinates here are such that xy dot north wall is not there, if that is the case, go to try again. And if the same is true the other way around with the west walls. I think that looks correct to me. So I guess we're good with that. So what this will do is it'll just, you know, go straight back to the top, generate yet another random maze, and then just carry on with the rest of the mazes. All right. So at this point, I've written quite a lot of code without actually running any of it or testing it. So I'm going to run this for the first time now, and it's probably going to go wrong. But the first time I'm going to do is fix all these compiler errors, because I do remember I renamed map data to final map data. So I need to change all of these references. Oops. Let's put that there, that there, that there, that there. Any others? Let's see here. There, there, there. And I really don't need that warning. What was it called? A disable. There we go. There we go. Right, that should do that. Okay, now it compiles. Let's run it and fully expect it to break in many ways, but oh, it looks to be functional. I didn't get an exception, didn't crash anything. Oh, and there's even a floor marking. So we have alpha, delta, there's another alpha. Okay, so we have blank blank delta blank blank alpha. Let's see if that's here. Blank blank alpha blank blank delta doesn't seem to be here. See if it's here. If any of you can see it. Ah, bingo. Blank blank delta blank blank alpha. That looks correct. So if I turn around here and go here, and then here should be a delta. Yep, I am in this maze definitely. And we're looking at a south. Alright, and you know what, I'm just gonna look here. The column is 1, the row is 7, and the cardinal is south. So 1, 7 means we are here, and we want to find this wall. You know what, I'm just going to walk into this wall, and then take a look at this log message that gets generated, because that will tell me that the maze still has the same shape that it had last time. It does highlight the wall that I thought it did, and I am in the position that I thought I was. So I think the rule seed 1 is still totally working. So now, let's walk into the lion's den and change the rule seed. Here we go, 47. Okay, we have an argument out of range exception. Let's see what causes that. We want to go to the 3D maze map constructor in line 625. 625, here we go. Ah! Okay, while... interesting, how could this... So the only way that that can be out of range is if visited is empty. So does that mean that I forget to remove things from to-do? I mean, I do remove it from visited here. I do remove it from to-do here. So every time that I remove something from to-do, I also add... Oh, why am I removing it from visited here? That doesn't make any sense. I want to keep the green cells green, obviously. It's only when it's done that I want to remove it from visited. That should be a given. Alright, that looks like... okay. We now have a BDH map. Right, so the column and so the indicator rules obviously haven't changed. So it seems that I can navigate this maze. Let's see if I can find... Oh, there we go, there's a cardinal. Let's see if I can find any of the floor markings. Ooh, there is a problem here. You see that? This maze is totally shut off. So I'm gonna run into a wall and take a look at the log message. And indeed, we are stuck in this corridor here, and that doesn't seem to be connected to any of the rest of the maze. So how did that happen? That is not supposed to be possible, because what I do at the start is generate a maze that has everything connected, and then after that, I remove random walls. So what I'm going to do is I'm going to comment out the part that removes the random walls here, and see what happens then. Okay, it is now going to choose ACH, but we had BDH last time, right? We had BDH, so I'm going to choose BDH this time as well, which is the second last one, so it'll be 8, I think. Yes, there you go, that's BDH. So let's look at that log message. That looks very different from what we saw last time. Was it not BDH? Was it BCH maybe? This maze still has an empty cell here, which is obviously wrong. Everything else, however... Oh, no. This part here includes that, but it's also not connected to the entire rest of the maze. So there is a major bug here. So let's go through the code again and see if we understand what's wrong here. For those of you who watched my live stream on the corners module, you may remember that back then I was able to implement the entire algorithm without a bug. I was quite proud of that, but as you can see, I cannot always repeat the feat. So right now I'm going to have to check this. Okay, so we start with everything in to-do except one of them, which we add to visited and remove from to-do. Yeah, that is our start index. Alright. So at this point, visited will have one element, correct. So while to-do.count is greater than 0, we pick a random cell from the visited, which is the green ones, pick a cell, and then see what walls are valid. Well, each of the 4 cardinal directions has a neighbor, which I've written this here. Let me quickly check that the neighbor function gives me the correct cell. For the north, we want to reduce the y-coordinate. For east, we want to add to the x-coordinate. For south, we want to add to the y-coordinate. And west, we do this. Yeah, that seems correct to me. Yeah, I cannot find an error here. And then find out where the to-do list, which is the blue cells, contains that neighboring cell. Okay, so if there aren't any valid walls left, then we take it out of visited and make it done. That's what marks it as yellow. Yes. I think this much is correct. And now if we do have a valid wall to choose from, then we choose one, grab that wall, and depending on the direction... Bingo, this is where the problem is. Because wall.cell contains the neighbor. What we actually want is the cell. Yeah. So for the north wall, we actually just want the cell. For the west wall, we also want just the cell. And then for the south wall, we can actually literally just use wall.cell, which is already the neighbor. So the south wall is the north wall of the neighbor, and the east wall is the west wall of the neighbor. This should be correct now. Alright, whoops, let's go back to the Unity test harness. Here we go. Now, if we run into a random wall, boink, let's take a look at this. Now that is a nice and connected maze. It looks like everything... No, 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 look at this. There is still a wall that goes right through the middle of it. Well, actually, that's not an issue, right? Because it wraps around, so you can get around that wall by going off the left edge and coming... Yeah, so this is perfectly fine. In fact, you would expect there also to be a wall going from the left to the right. And in fact, there is one. It goes here, down here, down here, and here. And that also divides the entire maze. You know, it would divide the entire maze if you couldn't... wait a second. Oh, wait. Am I wrong? Because I'm suddenly thinking... Ooh, yeah. Wait. No, this is fine, right? So this entire left half can be reached from the right half by just going through the right edge. And this entire top part, all of it, can be reached from this little part either by going out to the left or going through this... okay, right. So in order to reach this top part from here, you have to go out the left here, come in here, go up, and then go out the right again to end up here. And that's how you can visit the rest of that maze. So, it's all connected. Everything is connected in the great 3D maze. Alright. So, well, hey, it's a real maze. Yes, it totally is. Okay, now we are going to remove 20 to 35% of the remaining walls. And let's see what our BDH maze looks like now. Let's just walk into a wall here. And we have all of this stuff. That didn't seem to have removed much. In fact, I don't think this has removed anything. Or maybe it has. I'm going to... Oh, I have an idea. Wait a second. Let me try something. If I walk into a wall again, and then take a look at this log message, right? You can see that the cardinals and the labels are still in the same places. It's only the decoy directions that have changed, that have moved, and of course the player position and the goal position. So this is fine. So it does generate the same maze. So now I want to compare the one without the removal to the one with removal. Alright, so this is the one with removal. Let's run the same code again without the removal and see just how much more there is in terms of walls. Let's run into a random wall here. Let's look at this. Oh, look at this. See, the reason this is completely different is because it must have decided to remove this one wall, or maybe this one wall, and that would cause it to generate an entire horizontal or vertical corridor. And so it decides to just try again, and that's why we get a completely different maze. So let's run this same comparison with the ABC maze, right? The maze 0, which we can select here. Alright, let's walk into a wall. Here we go. That's that. And now let's generate the same one again with the... let's do this so I can easily switch between the two. Okay, so just delete that and replace it with this log message. Selected map. Oh yeah, I need to walk into a wall. There you go. Here we go. And again, it probably decided to remove this wall and then ended up with a straight and long corridor. Well, you know what? I think it works. I think it looks like it's working. So I think I'm going to keep this. I mean, it would have been nice to see the comparison. You know, actually, I have an idea. I'm going to output a log message every time that I do the try again thing here. Right, I'm going to say debug.log retried labels, that's a string, right? Yes. And then do the same thing here. And then we will be able to see in the logging which of the mazes did not have the retry thing. Bang. Let's see. Oh my lord, it seems to retry quite a lot of times. ABC, ABD, ABH, ACD, ACH, ADH, so all of the A's, BCD, BCH and CDH. Those have only one retry, which is relatively low compared to the others, but it's still greater than 0. So here's what I'm going to do. I'm going to reduce the likelihood of creating such a corridor by not removing walls that would create such a corridor. No, actually, you know what? I don't know. It's not worth the complexity. It would be, you know, what I would have to do is I would have to remove those contentious walls from this array, and I don't know. That logic is not really. That's nice to hear, Andrea. Oh, would it be better to check whether it would make such a loop and just not remove the wall in that case? Ah, okay, yeah. Yeah, okay, you know what? I'm going to do that. I hope that you guys will find that interesting. So, but make sure not to remove a wall. But we will still need to perform the check though, because the initial maze wait. The initial maze generator cannot create such a corridor, because that would be a loop. And the initial yeah, that's right. The initial algorithm never creates a loop. So, but make sure not to remove a wall that would leave an entire row or column devoid of walls. Alright, now here's another issue, because you could have corridors with 2 walls, and you don't want it to remove both of those. So, I'm going to approach this differently. So first of all, let's add all of the walls. Shuffle them. No, actually, in this case, we will not shuffle them. Instead, we will choose a random wall, see if it's a candidate for removal, and yeah, let's do that. Let's do that. So this is the number of walls we want to remove. Pick a wall, any wall, var wall equals remaining walls, rnd.next 0 remaining walls dot count. Okay. So now make sure not to remove a wall that would leave an entire row or column devoid of walls. Close parenthesis missing here. Hello everybody. Hello Ray. Welcome to the stream. What's going on is that I'm adding rule seed support to 3D Maze, and I'm afraid you've already missed quite a lot of the amazing parts. I can show you this here quickly. This is one of the randomly generated mazes, but as you can see, it is pretty pretty not connected. Like, there's a lot of walls in there compared to the kinds of mazes that we had in the manual, but we'll check that. So first of all, let's do this. Make sure not to remove a wall that would leave an entire row or column devoid of walls. So our num walls in row equals enumerable range 0 to width count. So for each x coordinate, see if map data of okay, so I guess I do want this now. This is the x coordinate, this is the y coordinate. Oops, I wanted a double x. So I want to see if that one in the row that we are in, if that one has a east wall, west wall. I keep saying east wall when I mean west wall. So if that, so count that, and if that is equal to 1, then, well, we are going to remove it from that index anyway, aren't we? So, so let's make the wall index that, wall index, wall index. So if that is the case, then we continue. And now, this would not actually remove a wall. So I'm going to say while remove walls is greater than 0, and then I'm going to deduct that, or decrement that. So, make sure not to remove a wall that will leave an entire row or column. So we need to count the number of walls in the column. And it just occurred to me that, of course, I can literally just inline that. So I'm going to do that. So let's see if all the y coordinates are such that there's a north wall. So if there is only one north wall in that entire column, and why, oh, that I, that needs to be wall. So, right, so here we can use x and y then, I guess. It just occurred to me that, oh, yeah. So we only need to do this check if we're removing a west wall. So we do this. Else, we do this when there is a north wall. Make sure not to remove a wall that would leave an entire row devoid of walls, an entire column. Okay. Yeah. Okay. Let's see. Okay, I think this sounds good. So I'm going to. We still have these log messages, so we should now never see these log messages. So let's make sure that that is the case. Whoops. Let's run the test harness. Here we go. Has it already been 3 hours? Yeah, I guess it has, hasn't it? Alright, let's take a look at this map. This is the ABC map. Alright, we do have 2 A's in a row here, but you know, they're 1 space apart, so it's not that big a deal. And we can see that the maze is a little sparser now. We have like individual walls in the middle of the space, so that looks good. Let's take a look at the other mazes, because this is the ABC maze. I guess I can close this. 1 hour 48 minutes, is that what it's been? I don't remember what time I started. Anyway, so let's select a random maze again, and let's just take a look. So we've seen the ABC maze. Here is the CDH maze. Let's take a look at that one. Click. And this is what CDH looks like. That looks a little bit tighter, but not that tight. Like there is still a bit of a hallway here, a bit of a hallway here. I think I am happy with this result. Not Andrew, Spare Wizard, let me know if you have any, any objections or anything, or any suggestions. I think this is cool. So with this out of the way, I guess the one thing that I need to the only thing that's left now is to do the same thing in the manual. So in the manual, I need to generate the SVG. I need to generate the exact same maze and then generate an SVG from it. So let's tackle that, shall we? First, let's close the... I'm going to leave this open here, and I'm going to write down that there's a CDH under rule seat 47. And then we will later see... Okay, and by the way, 3D Maze is one of the most translated manuals. I don't know if you even knew that, Spare Wizard. We have translations into Czech, German, Spanish, Esperanto, Hungarian, Bulgarian, Arabic, Thai, and Chinese. I am going to try to update all of them when I'm done, but maybe not on the stream. Someone here did Germanian, whatever that is. Okay. So let me quickly take a look at how I actually did these SVGs. I remember making them, but my memory of this is a little vague. So let's save this as temp.svg, I guess. Overwrite that, run that. And let me see that in Inkscape. It's already obvious that all of this is text objects and the walls are all in a single path object. Let's see how that looks. Okay. That's what I suspected. They are pretty yeah, they are perfect, just perfect. So I am pretty sure that I still have the algorithm that I used to generate this SVG. So let's see if we can find that algorithm. It's going to be here somewhere in KTANE stuff. And this algorithm is quite interesting. Let's see, 3D maze, there we go. Do 3D maze manual. Oh, look at this. And here we go. Here we have a hard coding of all the... you can even tell that this was probably copied from the 3D maze source code. Right, so let's see what I do here. Create 2D maze SVG. Here we go. This is the algorithm that we had. And this uses a 2D Boolean array of north walls, west walls, and of course the labels, which you know we don't need for the walls obviously, but it's still part of the SVG. I'm going to get to that in a second. All right, so let's let me just quickly see what, because I'm pretty sure that this uses some other algorithm I wrote somewhere. Oh, I recognize this algorithm. Okay, so it doesn't call another algorithm. I've actually copied it. Now W, I'm pretty sure, yeah, that's like one of these. There we go, that's W. It just checks if there is a west wall from... okay. Right. So we are going to need to translate this algorithm into JavaScript. But before I do that, I'm going to start by translating the... No. I am going to do this first, and I'm going to test it on rule seed 1. Because we know what that needs to look like, so we can... this is cool. Okay. We are going to generate ourselves some SVG mazes, ladies and gentlemen. This is going to be really cool. I'm going to enjoy this. I already know it. Okay. So, first, let's add the JavaScript reference here to the ruleseed.js. And then let's add a script tag which defines two functions, the setRules function for non-standard rule seeds, and then the setDefaultRules function for the default rule seed. And I'm going to use a new function, render SVG, and I'm going to pass it a maze, and then I'm going to take all of this C# code here and try and translate this. Here we go. All right, let's see. So we have north walls, west walls, labels. I'm going to get to that in a second. In fact, you know what? Since I've already mentioned this twice, I'm going to mention this now. You may remember that when I first opened the manual, I mentioned that there is something called an embellished manual. In fact, there are two of them, but it's the bottom one that I'm referring to. So what's the difference between the original manual and the embellished manual? Well, that isn't even this is the embellished manual. All right. So one difference is that it lists the indicators rather than just telling you the phrase, but that's beside the point. The main difference is that in this manual, you only see the letters, which means that if the diffuser says, for example, blank A, blank B, then you have to, look through the entire maze to find it. So one embellishment that we created is to highlight all of the corridors from wall to wall that contain at least two letters and that are unique, as in no other corridors have the exact same pattern. Only the CDH maze has corridors that are ambiguous, and in fact it has 3 copies of the same pattern. And in this case, you have to use, the geometry of the walls next to, for example, the D and the last cell, whatever. So I'm, since I generated this with an algorithm, I'm just going to translate the entire algorithm that does that. And so the embellished manual will have those markings as well at every rule seed. So I am going to create this with the embellishment first, and then I'm going to remove the embellishments for the, quote-unquote original manual. So I'm going to start with the, right, okay, so this, let me see what this actually returns. This actually returns a piece of SVG code. So I guess I'm yeah, I'm just gonna do this. Okay, so obviously we're not gonna have types in JavaScript, so we remove these. I'm also not going to make this optional because we do want the labels in the maze. Highlight corridors, frame, omit axes. I do not remember what these do. Let me take a quick look at what frame does. Let's see. So this function is supposed to determine if there is a north wall from that coordinate x, y. And it just says true if frame is true and the y. So this means that this will... Oh, now I remember why I did that. Okay, so what this does is it will add walls around the edge of the maze even if this Boolean array doesn't contain those mazes on the edge. And the reason I did that is for another module, namely mouse in the maze, which I suppose I can add rule seed support to as well at some point in the future. You see, this one here has walls all around the edge, so yeah, so that's why I had that. So I can safely remove that from the JavaScript. What about omit axes? Is that even used? Ah, I see axes. Axes are these numbers here, the 0, 1, 2, 3, 4, 6, 7, which in mouse in the maze do not exist. So for mouse in the maze, I needed omit axes to be true, but for this one, this is going to be false. And then finally, string extra. What is that? Okay, that literally just adds something extra to the SVG. Now it just occurred to me that I can find all calls to this, and I will notice that there you go, 3D maze and mouse in the maze. This is exactly what I just said. So for the 3D maze thing, we we say highlight corridors. You know, there is a true and a false there. But as you can see, frame, omit axes, and extra are all at their default values. So false, false, and null. And this one here, you can see this one explicitly sets frame to true, omit axis to true, and it has this extra thing. Aha, the extra thing is, of course, the torus in the middle of the maze, which is this thing here. Now I'm a bit surprised that there are two circle objects here, both in the same place. Ah, okay. One filled with gray and then the other one filled with white. I suppose I could have used stroke there instead, but doesn't make much difference. Anyway, so enough of that reminiscing about mouse in the maze. Let's go back to 3D maze, which is what we are actually here for. So frame is going to be false, so I'm just going to do this and this. Does any other piece of code use frame? No, it does not look like it. So omit axes. There you go. So omit axes is now false. So that means offset is now 14. Omit axis is now always false. So we do want this, we do want this. Any other occurrences of that? Not quite sure I paid enough attention. Yep, that is the only occurrence, so we can get rid of that. Now what about extra? That is used in only one place. Yep, and we can safely just get rid of that because we don't need that. We need that only for mouse in the maze. Now, let's get cracking. We don't need any of this. I'm going to replace all occurrences of var with let, because that's what I want to use in JavaScript. Right, then dot length, I guess I'm going to change the capitalization of that. There we go, 6 occurrences, and I bet that there's going to be a dot count as well. I can see that there is a dot count with a lambda expression, so I'll get to that later. Alright, so I don't want to throw any exceptions here. I just want to trust the code that it has the right values. You know, I could actually just set this to, you know, to 8, because we know that 3D maze is going to be 8. But I want to keep the code. You know, now that I think about it, I am going to have to do this again for mouse in the maze. So, you know what, I'm going to reverse my decision. I'm going to include support for omit axes and frame. So I'm going to leave that in. And I'm just going to always pass in false. So when I do the right here, I'm going to say this, and right now I'm going to pretend that I have these three, but then for highlight corridors I'm going to say false, because this is not the cheat sheet. Bool frame is false, emit axis is false, and extra is null. And then I will use them later for mouse in the maze. There we go. There we go. Okay, so now we can once again get rid of this, and also, you know, change all of that, which I already said. Length to length. Let's do that. Okay, so let's do this. Yep, let's do all of that, and let's do that. Okay, now these are functions, all right? So I can literally just say function n x, y, return all of that. So that's the function that determines whether there is a north wall at any particular position, and it seems to me that the rest of the syntax is fine. Now we do the same thing with w. We can just say x, y there, return all of this. There you go, and that's our w function. Now, is cell. Okay. I didn't think I wanted to explain how this algorithm works, but I think I'm going to explain what this algorithm actually does, because I think it's actually pretty interesting. So I'm going to use another Inkscape bit here, and let's pretend, you know, I shouldn't have needed to. Yeah, okay. Let's just finish generating this maze, right? So I'm just gonna do some random stuff here to just generate a random maze. So let's make that green, I guess, and remove that wall. Remove that wall, make that green. Remove that wall, make that green. Remove that wall, make that green. Let's just do some random stuff. Go here and here, I guess, which removes that wall. And then I guess we can this almost looks like, you know, a loop, but it isn't, because there is a wall here. Right, and then finally, I guess we can go from here into here. So let's say we have a maze like this. And I suppose at this point I can remove all of these green squares. Okay, so let's say we have a maze like this. So here's what the algorithm actually does. So we want the maze to look something like this. Now you could, of course, just draw lines, like I literally just did. But that would be too easy, wouldn't it? That is not what I wanted to do. The reason I didn't want to do this, by the way, this is not quite apparent right now, but at the time that I did this, I don't know if this is still the case, but browsers were really lousy at rendering this, and what this would end up looking like was something like this. And you would constantly have these lines sort of overlapping or standing out, and I really, really didn't want that. So what I did instead is I wrote an algorithm that turns all of this into objects that look a bit more like this. Right? So you would have a wall that is, you know, not just a line with stroke, but rather an actual rectangle. And instead of having a separate rectangle for you know, every bit of wall, it would all be one object with all of the corner pieces separate vertices. All right. So how does the algorithm actually do that? Let me return back to the, yep, there you go. Now it's all lines again. So what it does, this is actually quite interesting. What it does is it pretends that there is a grid that is twice the size of the maze, right? So right now you would think that this is the grid, right? This is what the cells look like. But imagine you actually have a separate sort of extra row or column, and these walls are actually an entire row or column large. So instead of having this line, you know, actually I guess I can visualize this by making the width of this the same as the size of every cell. So if I make this like 10 pixels, yeah, there you go. So it would kind of look like this, except that, of course, then I will change the width of each of the cells and each of the columns and rows in such a way that it will look thin again, right? But this is essentially what it does. So this is the first step of what it does. Now the next step of what it does is it needs to trace the outline along the edge of these sort of black blocks. And that's what this algorithm does, right? It starts with a random x and y coordinate, and then trying to find some code here where I can show this. Oh, there you go, right. It goes through the entire maze, and as soon as it finds a wall, it will keep sort of walking along the wall to discover the entire outline. And then, wait a second, why is there a... Suddenly, I don't know why there is this. Oh, I see. Oh, I see. This is the... Is this... Ah, this is for the highlighting? Yeah, I see. Okay, so what this does is it creates the highlighting for the cheat sheet, and then later I will, include only the ones that are unique. Or rather, all the ones that have 2 letters. So ignore this part. Let's see. Now I'm really confused actually as to how this algorithm really works. But we did see it work, didn't we? Oh my god. Oh, now I figured it out. Okay, all of this is just for the cheat sheet, and the actual algorithm is in this one function here, bool's two paths. I knew that there was a function call somewhere and that I needed another function. So I'm gonna have to go back to the C# code and find that. Where is it? What was it called? Bool's two paths. So that one is the actual algorithm, right? Okay, I am getting a bit lost here. Okay, let's go here. Right, okay, it's here, right? And then that one, right, there you go, bool's two paths. So this is the actual interesting algorithm, right? There we go, it has a function called trace polygon. This is what I was talking about. So it goes through the entire map, and then as soon as it finds literally any sort of boundary between black and white, it will trace the entire polygon and then mark everything in that polygon as visited. Now the reason it says visited up arrow is because as you trace the outline of the maze, right, you might start, let's say, you might... Alright, let me go back to this... There you go. Alright, so you might start at this vertex here and point up. And then as you trace it, right, you might be here now and point to the right, and then you might be here and point down. So you see there are different directions that you can point at while you're tracing the outline. But it doesn't matter to check that you've visited every point in every direction, because any polygon will always contain at least one vertex where you need to go up. Right? That's a given. You can't only go right and down, because then you will never come back to the starting point. And therefore it's enough to find all of the points where you need to go up and then trace the entire rest of the polygon and remove it from consideration. So that's why that is the case. Okay, I hope that this explanation was somewhat elucidating, but now we realize that all of this code that I've copied is actually for the cheat sheet. And because of that, I think I'm going to remove this code for now, and I'm going to put that in later. In fact, instead of removing it, I think I'm just going to comment it out, because I don't need to worry about that before I do the cheat sheet. Okay, so let's just translate all of this code. That shouldn't be too hard. So isCell obviously is another function with 2 parameters, x, y. I'm not quite sure why. Okay, I see. isCell means that it's one of the white areas in this arrangement. This is why I started into this explanation at first, is because I saw this function and I wanted to tell you what it does. So as you can see, x and y is a cell only if both the x and the y coordinate are odd. Right? All of the even numbered rows and columns are walls. So that's what's going on here. Now isOn tells us whether a particular cell is black. Now a particular cell is black in many cases, right? So for example, right, let me actually move this down. So for example, this piece here, would be on because it is a wall. It's a wall between this cell, between this cell and the cell underneath, right? But what about this piece here, right? This isn't between neighboring cells. This is actually the corner between this cell and this cell, right? So we want that to be on whenever any one of the four walls around it is on. So that's why we have these multiple if conditions and this. Okay, yeah, there we go. So if it is in an even row, then we're looking at stuff in between. Okay, right. So if we're in an even column and an even row, then we're on one of these junction points that I just highlighted. So we want to check all four directions to see if any of them are walls. Otherwise, if we are in an even column but in an odd row, then we're looking at a horizontal wall. Sorry, at a vertical. Wait. If x is even. Okay, so it's the y coordinate that is now in a corridor. So we're looking. Yep, that means we're looking at a vertical wall. So we're looking at the west wall of some cell. And similarly, here we're looking at the north cell of some cell. And of course, if both of them are odd, then we're not looking at anything. We're looking at the contents, like the inner, like we're looking at this piece, right, or this. Yeah, these will always be white. There is never a wall inside the actual cell. So that's what this is_on function does. It tells you whether any particular part of this graphic is going to be black or white. All right, so we want to return this and remove that parenthesis. Which reminds me, I suspect that, yeah, this parenthesis is from the C# call, so that needs to, oh, I see, we want to return, there we go. Okay, so with that out of the way, there are some more functions here. All right, so let's define these functions. So getX apparently is a function that takes, okay, I see. This gives you the actual x coordinate of a grid location in the grid, right? So apparently I decided to make the cells 25 pixels wide and the walls 5 pixels. So that's what's going on here. All right, so for that we want to return this. And then here we do the same thing. For grid Y, return that. And then finally this. Okay, this is for the SVG path object, which I suppose I can show you by looking at this SVG here. You can see that this consists of coordinates, and in fact you can even see that these are all multiples of 25 plus a multiple of 5. Right, so 55 is 50 plus 5, and here's a 50, etc. So these are all the coordinates that this entire polygon is going to be made out of. Okay, so return. So we want an interpolated string consisting of the x coordinate, followed by a comma, followed by the y coordinate. There you go. Okay, now this is quite a big single return statement, but I think this should work. So I'm just going to replace all of this with whatever JavaScript requires. So we have this, 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 and this, and this, of course. Now, do we need extra? Well, I guess I'm going to keep that. Yeah, I did decide to keep that for mouse in the maze later, so I'm going to leave that. So this is for the cheat sheet, so I'm going to comment that out for now. In fact, comment out both of those lines. Polygons. Now this is what I was talking about. These are the polygons that represent the walls. So for this I'm going to have to copy the bools to path function from C# in a second. But first, let's see what this does. This generates an array of the right size, a two-dimensional array no less, by using the function is_on as, yeah, okay, so let's see if I can whatever I want to call that. Let's see, I want an array of size 2 times x size plus 1. Now I'm using a little trick here in JavaScript to get an array that consists of the numbers 0 to something, 0 to n minus 1. So I want that. And then for each entry here, map. So that would be an x coordinate, right? And then for each entry in there, no, this would be a y coordinate. No, it would be an x coordinate. Yeah, it would be an x. So apparently I decided to have the first key in the two-dimensional array be the x coordinate. All right, then we have the y size here, and that gives me a y. And then I want is on x, y. There we go. And there we go. And then that should give me a two-dimensional array. I'm heading out. Poke me on Discord if you need anything. Thank you, Spare Wizard. Thank you for following us up to this point. I do understand that this part of the algorithm is not that interesting anymore. But yeah, do drop by again if you ever feel, if you ever want to chat. Okay, so let's get back to this. So we now have this array. So I guess at this point I can literally just take that and put that here. Replace all of that with this. Okay, now each of those Boolean paths that this will return will get mapped to a polygon. Let's see. And now I need to figure out if JavaScript has this ability. So if I have an array consisting of two, let's see. Let's try this. Let's see what this gives me. Aha, that seems to have worked. Ah, bingo. Okay, so x is now the actual element from the array, and y is the index. So that works exactly the same as C#. That's very helpful. Thank you, JavaScript. So, if ix is equal to 0, we want an m. If ix equals 1, we want an l, else nothing. We don't actually need the L. It seems that when I made this, I didn't know that you can just start with an M and just do the whole thing. But I'm gonna leave this because I know that it works. Okay, so P, right, so what I'm doing here is I'm expecting an object that has an X and a Y property, so I'm gonna have to remember to make our bools2paths function return that. Alright, now join string is just called .join in JavaScript, and then we add the z, which ends the path in the SVG. Then we join all of that with spaces, and that's the end of the path object. That should be it. Okay, now, let's see. We're gonna remove this for now, because we're not doing the cheat sheet just yet. Okay, so here, yeah, so I'm gonna use the same trick again. We want x size things. I'm suddenly not sure if I wrote this correctly, so let me just quickly check if this works. So if I change that to a 5, yeah, okay, that does work. Very good. So we map that to this stuff. There. I'm quite surprised at the change of the formatting. I think I can. Nah, I'll not do that. Right, so join that with nothing. Okay, so this is the closed parenthesis. Wait, what is this? What is this? That should match up with this. Okay, it just doesn't recognize that this is the matching parenthesis for this, and this is the matching parenthesis for that. So that works. Right, now row headers. This is basically the same as this. So we'll just do this, except that it says y size instead of x size. Not that it matters, because both Mouse in the Maze and 3D Maze both have square maze sizes. There we go, join. Alright, and that's the row headers, and now we have these labels. Okay, so if labels is null, then we don't want any. So here I'm going to use an empty string, because otherwise JavaScript is going to turn that into... Actually, I don't know if JavaScript is going to turn that into anything, but anyway. Right, so we want all of the labels. Yeah, let's do that. Okay. So this is for the numbers from 0 to 9. It just occurred to me that what happens if I just do this and then map this? Yeah, whatever. So maybe I don't need that dot 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 syntax around. That's what I suspected. Okay, so I do need that. Alright then. So I want an array with 9 elements. Why 9? Wait a second. Really, why 9? Okay, let me think about why there is why it says 9. Is Mouse in the Maze 9 by 9? 2, 4, 6, 8. No, this is 10. So why would I have a 9 in this code? Oh. Is that why? Okay, I cannot currently figure out why this is going up to 9. Let me just quickly look at the C# equivalent of this code. Where am I using this? Right, it seems here that I'm checking that it's less than 8, and if it's not, then I just always put null there. So I'm not quite sure why I had it go up to 9. If anything, it should be 10, shouldn't it? Because Mouse in the Maze is 10. But for 3D Maze, I'm just going to hardcode an 8 in there. So these are the rows. Alright, and then here we're gonna do the columns. Okay, so now they're always less than 8, so I can remove these conditions. So if that is a label that is not equal to a space, then we put this text object there. There you go. So that text object obviously is the label, which is the floor markings or the asterisk for the cardinals. Else we do nothing, and this is the map, and then we join these, and then that is the outer map, so we join those, and then that is the entire piece of code there. Alright. Whew. Yeah, I think I want to format this similarly to the C# code, so this is what I want to do. Okay, so far so good. So now that we've done that, I need to I now need to translate this bulls to paths. Here we go. Let's see. This is our function. Yep. Okay. So function bulls to paths. Okay. So what does this take? This takes a two-dimensional array of booleans. So I'm just going to call it bools, I guess. Does it have any other parameters? Let's see. We map this. It does not. Okay, so that's literally it. Okay, so let's find the bulls to paths function here and translate. As you can see, this is relatively small. Oh, trace polygon. Oh yeah, that one's a bit bigger, but it's repetitive, so it's going to be easy. All right, so bulls to paths. Let's just copy this. I called it input, so let's call it input. Let's see. That has a length. That has a length. So results equals, right, that's just a list. And then these are things that are visited. Apparently I wanted that to be an array, so I guess I'm going to make that an array okay, this is going to be a two-dimensional array. So I'm going to say, I'm very surprised that I used the x-coordinate as the first index, but that's fine. So I guess I'm gonna use width keys, and then do this trick again. Map, and then for each of these columns, I guess I'm going to create another one of those where height is and then each value in here is a false. Okay. So for each value from right, okay, so every region must have at least one up arrow. I already explained that earlier, I hope you remember. So if not, visited up arrow that, and input.get. Now input is a two-dimensional array. So at this point, I can just do ij. But the reason I had this get function here is because, yeah, there it is. Yeah, so it's so that I can safely ask it for values outside of the array, and it would always just return false. So I guess I'll write such a function again. So function get from an array, I guess ij, let's call it that. So if the array.length, so if I is less than 0 or greater or equal to the length of the array, then we want to return false. Else, if j is less than 0 or j is greater than or equal to the length of the array at position I, then again false. Else it's array ij. Okay. So I guess I'm, just for consistency, I'm going to use the same function in both cases. So I goes from 0 to width. So I is basically an x-coordinate. I see. So this is I see. This is checking a vertical wall, right? This is checking whether this cell is black and this cell is white, because it says not, and I almost forgot to put input there. All right. So we now need to add something to the results, trace polygon, and that should be it. And then we just return results. Right. So let's translate this trace polygon function. Oh my gosh, this is quite a lot of code. Rather, it looks like a lot of code, but it's not going to be that bad. Okay, function trace polygon. So we have an input array, an I, a j, and then this double Boolean array that tells us what has already been visited, because we need to mark things as visited as we trace them. All right. So the result is going to be a list, and the direction is going to be up. Okay, so I think I'm just going to say let up equals 0, and then let's see what values they have here. Yeah, it's unusual for me to have them in that order, because usually I want them in clockwise order. But I guess for this algorithm that probably works. Okay, so let the direction be up. So I guess I can remove this everywhere, because all of that is just going to be up, down, left, right. In each iteration we move from the current edge to the next one. We have to prioritize right turns so that the diagonal adjacent every time we take a 90-degree turn, we add the corner coordinate to the result list. When we get back to the original edge, the polygon is complete. Okay. So, I have a strong suspicion that we can probably just do a few search and replaces here, and be done with it. So let's see. We return result here. That's a true. Okay. We need to change the calls to .get. So every time it goes input.get open parenthesis, we actually want get input comma, like this. Bang. Okay, and of course result.add is actually result.push, bang, and new point of something, comma, something, close parenthesis, I should do this, is instead literally just x and y. And that should work. Yep, that seems to have worked. You can see here and here. Okay, what else? I think the rest is fine. Right, I told you this was gonna be quick. Now at the end of this, no, okay, we don't do it at the end because it's here when we find, you know, when we come back to the start of the polygon that will return the whole thing. All right, so that's trace polygon done. So that's that done, and that adds it to the results. And so we can go back to here, and this expects a list of lists of points, right? Let's check that. So after this call, yeah, that's right, each polygon is a list of points, and each point gets put into getQuartz. All right, I think I'm done with this. I think I'm finished. So now the next thing I need to do is put in the default maze, which I can do by looking at this piece of code here. Here we go. So for each map index, let's see. Yeah, I think I'm just going to copy all of this code and then see what to do with it. Okay, so we don't need the outputs to be in a list of strings. We're going to put them directly into the HTML elements. Let's see, cheat sheet. This is going to be false right here, but I want to keep the code around so that later when I do the cheat sheet that I will have it available. So we want to split this, we want to map that to something with interpolation. There we go. So that's a div tag, that's the end of the map, don't need that. And then for all of these. Okay. So I'm a bit annoyed that the coloring here is not working, so I think I'm gonna do this. That doesn't seem to have fixed it. Oh, I see. Bingo, that seems to fix it. Right, that is a bit of a dumb trick that I have to do there, but you know, is that dumber or less dumb? I don't know. You know, whatever. Let's just do this. Okay. So for each map we have labels N walls and W walls, and these are all of the maps. Okay, and so we want to change the syntax from new string, all of that, and that should be a curly, to literally just square bracket, all of that, square bracket, done. Okay, that has added some extra spaces around, so I want to do that again. Oh yeah, of course, the spaces are already there, so we just do that. There you go. Okay. I don't think we need any other stuff here, so let's move on to this. Now, instead of outputs.add, I want to add this to the correct place in the HTML. So let's take a look at this. Apparently we have these tmaze outer things, and then we have TDs. Okay, let's see, in 3D maze, right, we have, I want to take a look at this, right, we actually have a table where each row has 2 mazes. So I think I'm going to give the TD elements a class name. All of these TDs are going to have a, so TD gets replaced with class equals tmaze TD. I'm just going to call it that. Let's do that. And there were 6 occurrences, which is correct because there are 6 mazes on page 2, and I forgot to mark to select the second page, the third page rather, and that will provide us with another 4 chain occurrences. Alright, there we go. Right, now I'm going to get the TD objects here, document.getElements by class name tMazeTD, and then here, yeah, that should be correct. TDs at the current maze index. Is it maze index? Map index. It was called map index. Dot inner HTML is equal to all of that. Okay, so let's see. This is some some C# syntax that JavaScript doesn't have, so I'm gonna have to say if this is null, then nothing else. Headers map index. There you go. So that's for the headers, and then we do this create 2D maze SVG, which we just wrote. All of this should be map. These should be map. Okay, there you go. So we check if it's a 1 and turn that into a 2-level array. There we go. The labels. Yeah, I guess I can literally just leave that way. Let me see how this function here handles the labels. Yeah, okay, so this will be the labels for a specific row, and okay, maybe let me just quickly see if I can do this. Yeah, I can do that in a string, so this will work. It will give me the character at a specific position, and it'll check whether that character is, you know, a space or an asterisk. Okay, so that should work. So let's see, /div, and then that should be it. Now if I run this code, well, without the rule C, let's go. All right. And I probably get an error. I did not get an error. Now, in order to make sure that this actually works, I would be very surprised if this already works. It's very likely that these mazes here are literally the originals. So I'm just, for now, going to remove the SVGs from this entire bit here. Why did that not work? Because that removed 10 mazes, and now if I oh my gosh, the mazes are still there. Oh, it's because I'm looking at the live site and not at my local. Right, obviously the mazes are not there. Syntax error. Okay, this looks much more likely. I was really not sure there if that was even plausible that I got all of that right. So let's see. Yeah, I think this is where that string ended. Yeah, that looks correct. Let's see, syntax error, n-walls is not defined. That's here. N-walls, oh, I see. Yeah, I already called create maze there. Okay, so this should instead say this. And then we want false, false, and nothing. Right? Instead of null, I want extra to be the empty string actually. Okay, so we are seeing something. Now, why is it not quite? Oh, I see. I actually removed the SVG tag. I probably should not have done that. Let's see. So these are all the outputs. No, wait, there is a div, and the div will contain the SVG, right? Yeah, I did not remove the SVG tag. The SVG tag is right here. Alright, so we need to figure out what's going on here, so let's take a look at the inspector. Right, it looks like we do have a TD, we do have this div. Ooh, aha, there is a $sign missing. That is something that I should have noticed. Let's run that again. And now there's probably another error. Row.map is not a function, line 150. Let's go here. Okay, n-walls. What is n-walls? I want to change that to let, but okay, so n-walls should have been set to one of these arrays. Oh, I see. So this map works. It's this one that's wrong. It's because row here is a string. So I'm going to do this, and that will replace a string with an array of all of its characters. I can just check if that's true. Yep, there you go. That changes a string into an array. All right. Let's refresh this page, and now we have an undefined function in line 163. Walls, W walls is undefined. Okay, so at this point I would need to know what the wait a second, this uses the y first and then the x. It looks like I'm confusing myself by sometimes using x first and then y, and sometimes y first and then x. That should ideally not be the case. But for now, let's continue with this. So let's see, where was this thrown? This was thrown in line 163. Yep, that's this one here. And it says that this is undefined. So that let me console.log w walls, because that's the one that causes it. So w walls is an array of 8 arrays, each with 8 values. So that means that it didn't calculate y size correctly. So let's see what that gives us. No, it did do that correctly. So if this is modulo 8, then surely that should always give us a value from 0 to 7. And same here. X size is also 8. So why would this be undefined? Let me do this again and take a closer look at this. I suppose what I can do is right here, I can log the x and y values. Ooh, 0. I see. Okay, because the integer division, you see, this is all relying on integer division in C#. And in JavaScript, you don't get that. You get, 0.5. Now I'm going to use a trick, because divided by 2 is actually the same as shift right 1. So I can actually just use that, and that will remain an integer. I can guarantee it. Right, I do want to make sure that the operator precedence remains correct, so I'm going to make sure that I have parentheses around things like this, and that seems to be okay. Now let me quickly look for other divisions. Aha! Whoops, let's change that also. Next one. Okay, it's gonna be right. Okay, let's go here. Is there any divisions here? Nope. That's HTML. That's HTML. Okay. That's there. That is looking good. I don't think any of this here uses division. Yep. No. Okay. This is fine. All right. Okay, it is starting to look more like what we're looking for. So I guess I can remove some of these logging things now, because it's gonna get out of hand if I just keep adding them everywhere. So now, let's see if it actually added the path object, and it did, and there are curly brackets in it, which means that, again, I forgot one of those dollar signs. Ah, there we go. And we've done it. Here we go. Our mazes are there. Right, now let's see if these are actually the exact same mazes as they are in the original, which I can look at here. Scroll to the bottom, and we can see they are exactly the same. Bingo! Alright, now we have this algorithm in our JavaScript, which means that we can very easily transfer that algorithm both to the cheat sheet and to Mouse in the Maze later. This is really cool. Alright. Now we need the maze generation algorithm. Alright, here we go. So, this is the default rule seed, which does all of this stuff. Yeah. Okay, so let's find the let's go back to the 3D maze module, And let's copy all of this code. This is going to be the rule-seeded code, and this is currently indented, so I'm gonna unindent that. Yeah, I think this is right, is it? Okay, like this. Okay, and here we go. So for each label let's see, I call that let. In fact, let's replace all vars with let. There we go. Oh yeah, we have the try again loop. I'm gonna have to use a trick for that because JavaScript doesn't have a goto. And I will show you that trick when we get to that in a second. Now here we need to change the syntax here to that. And then this is going to be a two-dimensional array. Now in this case, I am going to let me see. Let's see. I use this sort of two-dimensional array. Right. So the only way that I ever use that two-dimensional array is by, accessing an x and a y coordinate. And because JavaScript is, like I don't really have two-dimensional arrays in JavaScript. At least I don't think I do. Let me just quickly check that. If I do like, oh, I see. Obviously I can do this, but that would just be an array of arrays. So here, there you go. That's my A. I'm thinking that maybe that is what I want to do. I want it to be an array of arrays. Yep, you know what? That's what I'm going to do. I'm going to make it an array of arrays. So we're going to say array width dot keys dot map, and each of these is a column because it's x first, and then we do that same thing again, array width dot keys dot map, and now for each of these cells we want a map node object. Now map node has a label, a north wall and a west wall, and the labels, as you can see here, we all set them to spaces. In fact, you can also see that here, right? Oh, I see. Yeah, okay, so I can just put that in here, right? So I can just say label is a space, and then north wall is true, and west wall is true. And I do need to put parentheses around that. And there we go. And then I don't need this. Okay, now to do. Now we want all of these coordinate objects in a single list so that we can remove them individually. So we're going to do this. And it just occurred to me that we never actually declared this. This is 8. There you go. So we do this and map each index to a new object where the x coordinate is this, the y coordinate. Now again, we need to use integer division here, so I'm gonna take that bitwise OR that with 0, and that way we can round it down. Okay, and then we don't need this because JavaScript can do that. And let visited be an empty list, let done be an empty list. Choose a random square to start from. So from 0 to do.length, obviously this time. We push, right, I suppose I can change all the occurrences of add to push. There you go. And then remove add is the same as splice 1. Okay, now generate a maze. So while there's still stuff left to do, I guess I can change all occurrences of next to next. There you go. Okay, so, oh yeah, count. I want to change all count to length, lowercase. Okay, where were we? We were here. Okay, so valid walls. No, we were here. No, we were here. All right, valid walls. So for each of the 4, so here this time, because it's literally just 4 things, I'm just gonna write it like this. In fact, why don't I do this? North equals 0. What was it? South equals 1? I don't remember. South is 2. Okay, so east equals 1, south equals 2, and then west equals 3. And then here I guess I'm gonna say north, east, south, west. For each direction we have an object whose direction is direction and the cell is neighbor. We will need the neighbor function. Right, and then we want to filter this by whether todo.includes. Oh, no. This does not work with objects in JavaScript, so I'm going to have to use comparison lambda. So if any of these to-do cells has the same x coordinate as c.cell and the same y coordinate as c.cell, and I think I lowercase this. There you go. So that should be lowercase. So you can see here that I used the lowercase there. Right, I think I'm going to lowercase x and y as well, as I did here, as you can see. Right, so that means these should also be, right, okay, there we go, that's lowercase. Now let's quickly write the neighbor function. Function neighbor. This uses a cell and a direction. Let's take that, neighbor. Here we go. Put that switch statement here, and depending on that direction, return, right, okay, so instead of new coordinate open parenthesis, we're gonna say that x colon space, like that, and then that becomes that, like that, and then we need to give that the name y. There you go. That's a y, that's a y, that's a y, and then also replace these. There you go. Okay, that's the neighbor function done. So where was that used? That was used here. So that's where we are now. Oops. Right, we don't need the .toArray. Let's get rid of that. Okay. Valid walls. If valid walls.length, I guess we can replace that as well. Replace. Oh, come on. This is what you get for pressing the wrong button. Length, length. There you go. 2 occurrences. That wasn't really very much. Alright, so if there are no valid, right, remove add is the same as splice 1. Push we already have. Continue the while loop. Then choose a random wall out of the valid walls. Use that wall and then ask for its direction. And then depending on that direction, I think for the rest of this code I'm just going to replace all these x's with lowercase. There you go. Okay. I don't want to change all of those, so I'm going to change it up here where I first did this. I'm just going to call it the same thing as what it is in the C# version. And so what does this code do? Okay, .cell. I think I want to lowercase that as well. Let's do that. And once again we're here. Okay, so remove wall. Okay, so we need to find the place in to do. Yeah, okay. So we need to find where in to do this is. So to do equals to do.filter. So we want to make sure that the x is not equal to that x, or the y is not equal to that y. Okay, so that will remove that one coordinate from to do, and then we push it into visited, and then we do this here. We have a new list of remaining walls. If that map data n walls push, that's that. I don't see anything that needs changing here. Actually, I do. I think this needs to be a 2-dimensional array, which means that all of these need to be a 2-dimensional array. So I should probably do this, and make sure wherever I access this that seems to be the only places so far that I've accessed it. So let's see, we want this lowercased. That's the percentage. This is how many. Right, okay, so here we're going to use the same trick as before, just or that was 0 to get an integer. And now while we still need to remove walls, I guess I can remove this piece here. Okay, so we pick a random wall, remove add is the same as splice 1, and here once again, instead of divided by 2, I'm gonna go shift right 1, and then here, gonna use that. If that is the case, then okay, so here we are counting how many walls are already in that row. So let's see if I can do that in one line with JavaScript. Let's see, keys dot filter. So we want to filter all the x coordinate where map data xxy dot w wall is true, and if that has a length of 1. There you go. That should be correct, and then we can change that and that. And then this is going to be the same but with y and the north wall. There you go. Okay, make sure that there are now rows and columns entirely without walls, because that can make a maze unsolvable if the goal isn't that row and column. Now we need that try again thing, and it just occurred to me that I probably don't need these debug log messages either, because I only needed that to, you know, while I was testing it. So let's see, if this so if every y coordinate has this property that there is no wall, then go to try again. Now wait a second, why would that happen? Because we do make sure. Oh, that's right. This is why I had the log messages, wasn't it? I wanted to check if that ever happens, just as a sort of check. And as you can see, it doesn't happen. Let me just quickly pick a different rule seed. If that never happens, then I guess I can remove that code entirely. It doesn't seem to happen, which is what I expect, right? I do expect that the this part of the while loop already refrains from removing walls that would create this invalid state. So I don't need this, and I don't need the try again loop. So I won't get to show you my trick for doing, you know, for simulating a try again loop in JavaScript. So that's the removal of the walls. Now we want to add everything from visited into done. So I guess we do this, and then we shuffle that. Now the 5 of each letter. Oh, I see. This used to say add, and yeah, that's right. My search and replace that with push. So for each letter, labels.length for each I. Yeah, I think this is just the same code, so I can probably just leave it that way. Yeah, I think that should be good. So that would put the maze into the map data, right? Okay, but we don't actually want that, right? We want to output it to. Oh no, we do want that. So wait. Create 2D maze thingy stuff. Ah, okay, that's right. We want to create the same loop that we created here, where we have this for. Right, and I'm actually surprised that I didn't copy that part. Row serial code starts. Oh, I see. I did this for loop with the maze labels. So here's what I'm going to do. I'm just going to say this equals maze labels of map index, and then I'm just gonna copy this. Because the reason I do that is that so that now I have the map index variable, which gives me a number, and now I can copy these TDs just the same as before, and I can copy this this here. Yeah, I think I'm just gonna copy all of this. Come on, please go up. Yeah, so once this is done, I'm going to put that HTML into TD's map index. So TD's obviously is the table cell in the manual where we're going to put it. And that will just create the 2D maze. Oh, at this point now, I need to... Ooh, because this expects the north walls, west walls, and labels as arrays like this. So I am going to go through map data. Right, okay. So we have a set of... So the north walls are, of course... No, actually, in both cases, we want to go row by row, right? And then in each row, we want to go column by column. And then we want to see if map data at that place, where you have column first and then row, has a north wall. So that's for the north walls, and then we have the same for the west walls, and for the labels, I guess. So we're just going to go label, and because we want them to be strings, we're going to join the first level, but this is still going to be an array. Alright, and then cheat sheet in this case will be false, but I think I declared that inside of here. No, I did not. So I'll just set it to false here. Okay, this is where I put it, but you know what? Yeah, let's just put this declaration all the way at the top, and then when I do the cheat sheet, I literally just need to change that to true. Right, now let's see if that works. Alright, so here we have, yep, this is the one. So let's go to rule sheet 47, and nothing changed, which means we probably have a bug. Yeah, we do. Unexpected token, close parenthesis, 101. Alright, let's see. Okay, yep, there is simply an extra close parenthesis at the end. And then in line 174, okay, why is it complaining here? What was the error? Missing close parenthesis after argument list. Let's see, this. Okay, it must be somewhere in here. This is a set of maps. This matches up, this matches up. This matches up, and this, oh, there's a comma missing. There we go. Headers is not defined in line 150. Okay. So headers equals null. Well, headers, I think the reason we had headers was, what was headers again? I forgot what headers was. Let's go back to the KTANE stuff code and take a look at headers. Okay, headers. What is it? Oh, okay, I see. You can't see it here because the cheat sheet, right, it's these things up top. That's what's going on. So we do want those headers in cases of not, of cheat sheet, right? But, you know, in not cheat sheet we want nothing. So I think that should be it. And then headers is, of course, bingo, here, this is where it's defined. So I guess I'm going to just move that to here. And there we go. And then, right, so, yeah. So let's put the same thing here that I did in the other part of the code, which was this. Right, let's just copy this and put that here and refresh this page. Nope, that's the wrong page. I want to refresh this page. Alright, we seem to have some mazes. Oh my gosh, that looks like it's actually working. That is pretty cool. Now let's take a look at this maze here. This is CDH in rule sheet 47. Let me temporarily add the labels. I will remove them again afterwards. So let's just say true. There we go. CDH, okay, it's the last one. I should have known that. Okay, so let's see if that is the same maze as this. And as far as I can tell, that is indeed the exact same maze. Look at this, everything has worked just perfectly. All of the W's are in the places where asterisks are, and all of the Charlies, Deltas, hotels are in the same places. We are done. We are done with the main manual. Okay. So the next thing, well, let's take a look at a few of the rule sheets. So here's some more mazes. There's this. There's this. These look very different from the default. Ooh, this one looks very much like the default, but yeah, you can tell that the default mazes are handcrafted and these are totally random. So you get some places where there is little or just, you know, a little L shape or some stuff, and then other places where there's quite a dense jungle of walls, like here. You know, that's what you get when it's random. You get a bit of everything. Alright. So, I am done with the original manual. Now let's do the cheat sheet. Shall we? Okay, I'm going to go here and compare 3D maze. No, compare 3D maze, not translated, with the embellished manual. Here we go. And I'm going to, okay, there's some, yeah, that makes sense. Okay, why are there some extra CSS rules? Oh, because the cheat sheet has CSS rules for the headers and for the, yeah, that makes sense. All right, let's copy all of this into the clipboard. So I'm gonna take a copy. So these are some extra CSS rules that only the cheat sheet has. So I'm gonna do this, put all of the rule-seeded code in. There we go. And oh, there's even more than that. There you go. And then when I'm done with that, I am going to copy this into the style tag. There we go. That's where it should be. And now, let's take a look at the embellished manual, shall we? That seems to have not worked. Type error, TDs is undefined. Line 196. Let's see. Alright, so this is the line 196 in the original manual. So let's take a look at the embellished manual, 196. Cheat sheet. Oh, oh, of course. Yeah, that's because I didn't add the class declaration to the TD elements, which is like here. Alright, so I'm going to copy this over for now. There you go. And refresh this. Right, now we do have the mazes, but not the embellishments, because, as we know, I have commented this out. So, in the embellished manual, I'm going to put this code in and translate it from C#. And in the original manual, I'm literally just going to remove it. There we go. So, here, now I noticed that this is a single function called corridors SVG, and I think, there we go, it does call that. Yeah, that's cool. Right, so let's put this back in, put this back in, and in the original manual, come on, there you go, let's actually just remove those. There we go, the lines to do with the cheat sheet. Alright, so here, right, okay, so we want to translate this entire function. So we have a function called corridors SVG, takes no parameters, there we go, and then that. And here, we have, okay, so I'm just gonna make that an object. There we go. And then replace int with let, I guess, and var also. There weren't any. So, I guess I do want to change 8 to width. That's technically what I should be doing. This one here, no, because this is an x coordinate, this is a size. But I guess I'm gonna do this. And this. Okay. So let's see. Let markings start do while... Oh, this uses the function w. Does that mean that this function w, which I've declared here, is that used by any other code? Yes, it is. It's used by isOn. Okay. So we do want that. Alright. That should be width. Apply. Ah. Okay. Let's see equal to that. And then do this. Yeah, this is correct. Alright, now this is an well, you know what? I'm gonna make the same change here first. Because I'm gonna be making a lot of changes into places. So, if c equals that, there you go. So, next one, if markings.count, so that's the same as filter, and then dot length, and that. Okay, so filter dot length. And now we have some SVG code here. Change that. Put a dollar in front of all of the curlies. I guess I could do that with a search and replace. Ooh. Okay, so that 0 suggests that I'm using this to replace something somewhere else later. So let's find out where I'm doing that. I'm probably using a function called fmt. There you go, fmt. I see. I need to wait until later to find out whether it is ambiguous or not. Ah, that makes so much sense. That is really cool. Okay, so I'm going to replace this with something that I can more easily use in a regular expression. Something like this. In fact, it doesn't even need the 0. Yeah, but to make it more obvious that I'm actually replacing something, I'm gonna put another hashtag symbol there. Let's do the same here. Okay. This obviously needs to be an interpolated string, and this time I'm gonna do what I said earlier, which is this. And then I should do the same thing here. Change all of the open curlies to that. Change this and this. Okay. Now, instead of add a save, we have a dictionary, right? So I need to say if lines contains markings, if it doesn't contain, right? So if not markings in lines, then that needs to be an empty array, and then we push that. There you go. So okay, I think this is correct. I think this is complete. So let's here's some more stuff to do. Okay, so for each of these lines things, so select many. So what this is doing is it's taking all of the line objects from all of the dictionary values. So what I'm gonna do this differently. So I'm just gonna start with an empty string, and then for let key in object.keys line. So that will give me all the keys, and then we're gonna go through all the elements in that. So we have lines key, and that will be a list of strings containing SVG code, right? So let's see, so we want to append to str, and now in that string we want to replace this with Now let's see. We want to know if that length is greater than 1, right? So if that is greater than 1, or the reverse of the string is also in the dictionary. So I need a string reverse function. JavaScript string reverse. Let's see if there is already such a function. Looks like there isn't. Turns out that people are rewriting this. Oh wow, that is embarrassing. But yeah, I will use that code. So if that is greater than 1, or lines contains the key split into characters, then that whole thing reversed and then joined back. There we go. So if that is in lines, then the line is ambiguous, right? I think that needs to be, yeah, there you go. So if that is the case, then we want ambiguous, otherwise we want unique. And that is the end of our replace semicolon. So I think that's it. And then we return that. Okay, that was quite a lot of code. Now let's see if that just works right out of the box. I didn't think it would. Missing close parenthesis. Let's find that. That is somewhere here. I see. Oh yeah, I didn't actually translate this. We need to put $sign here, $sign here, and then this. And I'm willing to bet that there is another one. Nope, there isn't, but I just noticed this. And let me just quickly change that. So it turns out we don't get an error, but we also don't get those lines. So I'm quickly going to check if those lines are even there. And it turns out they are not. So let's see what we are getting. So I'm going to take a console log of key. I meant key equals lines key dot join. Hello there, Livio. What do you think of stand-up math? I've never played stand. Oh, that's not the name of a module. You're talking about the YouTuber stand-up maths. Yeah, I think he's good. Alright, now let's take a look at these log messages. It turns out there isn't a log message, so none of this code is being executed. Let me see if I can figure out why. Labels. Oops. Why am I pressing the wrong key? There you go, labels. Let's see where labels is. Oop, there's another example of that. Labels is defined up here, isn't it? Ooh. Okay, labels. Yeah, that's the labels for the maze. I think I've reused the variable label. Yeah, there we go. I've got labels here. And I've got labels, oh no, this is called headers, not labels, so that should be fine. Yeah, Matt's, what? No, it's Matt Parker. I've never heard of Trey Stone. So, what am I doing wrong? Let me see what labels contains here. That looks correct. First one is ABC, next one is ABD, and then we have ABH. These all look correct. Okay, so labels has the right code. Also, I think I do want to change that. So, does corridors SVG ever get called? Let's figure out if that is the case. Right, console log arguments, which should always be empty. Aha, it never gets called. So there is a bug. What is the bug? We determined that labels is not empty. Highlight corridors, is that false? Indeed it is false. or not, because I actually forgot to set this to true. And there we go. Now we get an error message as we wanted. Width is not defined. Let's just put that here. Markings.filter is not a function in line 329 here. So what is markings? Markings is a string. Okay, so I actually need to split that string, I guess. Either that, or... Wait a second, markings split... push. Oh, this is the wrong way around. Okay. So yeah, we do want markings to be a string because it needs to be the key of this dictionary. So I'm gonna use split here to filter that. And let's run this. Oh, of course, the same thing happens down here. So we need to split that. And then also fix those two lines. Lines of key is undefined. Okay, let's just output that, I guess. 0 equals undefined. Oh, of course, that should be an of. And we have something. Okay, so we have both yellow and red and black, and I'm not quite sure why we're getting the black, but we'll take a look at that later. Yeah, you know what? This looks fine. So I'm just going to remove that console log again. There we go. Refresh this. And now let's take a look at why this is... Okay, so it didn't always get replaced. Sometimes it still has that. So why would that be the case? Because it can occur multiple times because we have two... Right, okay, this is one of those big failings of JavaScript. You can't do multiple replaces without a regular expression. But I did prepare myself for a regular expression, so I'm happy with that. And I think we are done. I think that's it. Everything is working. Alright, so that's the embellished manual. Now, am I done with rulesy? No, I am not, because there are two more things that I want to change. One is these phrases here, Maze Gamer and Help I'm Lost. I think we can come up with a few more phrases and just let the module come up with, you know, several options, like 2 options. And the other one is that, you know, whether the row or the column is the first or the last numeric digit, we can change that to first and second, or last then first, and stuff like that. So, Livio, you didn't pay attention. So what happened here is, in the original manual, it doesn't mention any indicators. It says add 1 for every unlit indicator with a letter in this phrase. So changing the phrase changes the indicators. So the embellished sheet just lists the indicators, and then also mentions the phrase, but, you know, it's really just the phrase that defines this. So, let's come up with a few phrases, shall we? I guess we don't need this anymore. Alright. So, we have Maze Gamer. We have Help I'm Lost. What else do we have? Maze Corridor. Maze, Winding Maze. Adventure, I guess. Find the exit, discover, journey, on a journey, let's do that, upon discovery, let's do that, during adventure, no, adventuring, I guess, SOS, I'm, what's another word for lost? I guess SOS and help is different enough, because there are indicators with L Wait, hang on, loss already has an L, P, E, H. I don't think there's any indicator with H, E, or P, so actually that wouldn't make a difference. Ah, where am I? Very good, thank you. SOS, where am I? Very good idea. Show me around. Okay, I need assistance. That's a good idea, but it's a bit long. But actually, it doesn't have that many unique letters. Quite a few of them are repeated. So actually, I'm gonna go with it. Right, but another, something like Maze Gamer. Oh, maybe the Labyrinth, or Labyrinthian, or something. So Maze Gamer, Maze Traveler, Maze Traveler. What else? Pathfinder, Sojourner. Whoops. Yeah, let's call it that. Ah, let's also do Voyager. Where's the exit? Nice one. Go to the exit. And I guess find the wall works, because you do find a wall in this module. How about cardinal direction? What is this place? What is this place? Very good. Yeah, I think that's pretty much. I think that's quite good for now. Go in circles. How about that? Dead end. Turn around, I guess, is what you do in a dead end. Winding maze. Twisty passages. Right, I think this is from Adventure Game, isn't it? No. Was it actually 3D Maze that had this? Oh yeah, there, you're in a maze of twisty passages. Yay. Okay, so twisty passages, let's just call it that. What's this? Oh, the maintenance channel. Right. Okay, I'll take a look at that later. Let me just do that. Timwee, do you know the tube map from the top of your head? No, of course not. Who does? Alright, so these are 25 different phrases. So let's put these phrases in here. No, not here. Here. Good for you, Livio. Let's see. If rule seed equals 1, then right, we need 2 phrases, right? So so I'm gonna say string phrase. No. Yeah, I'm gonna say phrases equals new list of. No. It's definitely gonna be specifically 2 phrases, right? Phrase 1 and phrase 2. I'm not gonna say null because I'm gonna have to assign these. Let's see. So here, phrase 1 equals Maze Gamer. And actually, you know what? I'm gonna call this the row phrase so that I don't get confused by them. And then obviously phrase 2. Phrase 2 is the column phrase. Let's call that help I'm lost. And then in the rule seeded code, I'm gonna say var phrases equals let's see. Yeah, let's take all of these. No, let's do this. like that. Yeah, I'm gonna make that a list so that I can remove an item from it when I choose one, right? So our phrase, our row phrase is going to be first decide on an index, right? So get a number from 0 to phrases.count. And then the row phrase, of course, is that phrase, and then we want to remove it at that index, and then the column phrase is another phrase at another random index out of the remaining phrases. Okay, and then obviously here where it says, where does it decide on the, oh, I see, the position is already, okay. The position is passed in here, and x and y. Ooh, so that is a little problematic, because now we need to, I have an idea. Instead of and, y, and, yeah, instead of passing those in, here, I'm going to, this doesn't actually update this. Oh yeah, it does. Oh, there we go. Okay. So, yeah, I'm going to move this code into the maze thing, and I'm going to pass in the serial number and the lit indicators. So here's what I'm going to do. So instead of these, and I guess these either, because I'm just gonna generate the log messages right here. I'm gonna say we have a serial number, and we're going to have lit indicator characters and unlit indicator characters. Alright, and then here we're going to pass that in by saying bomb info, I guess, dot serial number, which gives me a string. Yep, that is correct. And then I want bomb info dot get indicators. Let's see, get on indicators. Dot join, like that, and then we want the off indicators joined, and that's it. Okay, and now we literally just move all of this code into here. Right. So we generate the mazes and the phrases. And then here, alright, so calculate the goal position from the edge work. Okay, serial num obviously is serial number. We called it that. Oh, okay, we can write this much more easily. We can just say we can just say serial number dot where the character is and then we want the first of those. No, just the first, there you go. And then for the last digit, we want the last. There you go. So we don't need any of that code. Don't need that variable anymore. Okay. So, oh, we actually need the separate list of indicators. Yeah, that makes sense. Right, let's go here. We actually need this to be string arrays. And then let's pass them in as string arrays. Get on indicators dot to array, get off indicators dot to array. Alright, and now let's get back here. Now this common letter, right, common letter, I don't think I need that function, so I'm just gonna delete it because So here, first of all, we want unlit indicators. So for each indicator, so if there is a common letter, we can do that by saying indicator dot intersect with the phrase, which is the right. So the unlit indicators are for the row phrase, right? So row phrase, and if there is any intersection between those, yeah, then num unlit plus plus. There we go. Yeah, and I think I'm going to call this unlit. And then here, this is going to be lit indicators, and just call it lit. And bar, I guess. Okay, so if lit dot intersect with the column phrase dot any, then we have a lit indicator. There you go. Let's actually write this here, so this will make the logging a little more. Okay, so this should be width. Right. I think that's good. So that gives us the row and the column, but the later code calls it end y and end x. So I guess that's what we're going to call it. Right, and I'm going to change that to var because I feel like it. Okay, and now let's see if that still works. I do need to make sure. Ooh, there's a compiler error. A local variable named ix. Okay, apparently I reused the variable name ix, so I'm just going to call this I. Don't really care that much. That seems to succeed. Alright, now I'm going to run this in rule seed 1 because I need to make sure that the the basic rules also work. So in this case, let's see, we have the so the column is calculated as the last digit plus the lit indicators. Last digit is a 9, and the CLR indicator is indeed lit, and it does contain a letter from Maze Gamer. But that was the column, so it should be in help I'm lost. CLR has an L in it. Okay, and we have no unlit indicator, so that's just the first digit, which is a 2. Let's run this again. Let's see, we have a 3 and a 3 and no indicators. Great. I want a case where I have an indicator that doesn't match. So here we have a sig indicator, but that also matches, because sig has a G, which is in Maze Gamer, and it has an I in help I'm lost. So Bob, help I'm lost has an O, so that makes sense. It seems to be pretty rare to get a non-matching indicator. Here, TRN, no, it still matches. We were messing around 100 LOD and got to level 15. That's quite irrelevant right now. Bingo, here we go. We have a lit car, but the lit indicators, there you go, lit indicators are looking for help I'm lost, and car has no letter in common with help I'm lost, so that is working. Okay, I got that right. Now let's take a look at rule C47, and all of a sudden, it won't actually say the phrases, what will it? Well, here's the thing. I'm going to output some logging here. So debug.log format. So first of all, do I actually have log messages here? Yeah, I do, which means I have the module ID. That's good. That's what I wanted. Okay, so 3D Maze using rule seed rnd.seed, and of course I want to say that even if the rule seed is 1, so let's do that. Put that here. And now I'm going to output the phrases, and I'm going to say the row phrase. Right, I'm gonna put that here. Alright, no, that's exactly the right place. Yeah, of course. So right, row phrase is this should be module ID, yep, module ID, and then row phrase. And I believe that I may have forgotten to put the module ID in the other one, which is, oh my gosh, there's so much code to scroll through. And yes, I was right. Module ID, there we go, that is required. Let's go back here. There we go, row phrase, column phrase, column phrase. Why do you put 3D maze in pointy brackets up there? The reason I do that is so that when the when the log file analyzer looks at the log file, you can still see this message in the filtered log, but not in the main log, right? So this is just a convention that I use to, because the log file analyzer looks for square brackets, so I'm just saying, don't show it in the main log. But you can still find it by looking for the angle brackets in the filtered log. All right, let's take a look at rule sheet 47. And it turns out the row phrase is still maze gamer, but the column phrase is now twisty passages. Do we have any lit indicators? No, we do not. So I want a lit indicator and see if it, there we go, Bob. Bob has, bingo, there we go, we have a lit Bob, and that has no letter in common with twisty passages, and so it doesn't count. And now we have unlit, look at that, we have unlit Bob and unlit Sig, and of course Bob isn't in Maze Gamer, but Sig has a G, so that counts. And here we have a lit FRK and a lit NSA, and the NSA counts because of the S and the A, I guess, but the TRN, wait a second, TRN has a T, and Maze Gamer doesn't have a T, because, no wait, we're talking about the columns. Alright, so columns, okay, the TRN is unlit, that's why. There you go, so unlit is here, that seems to be working. Okay, so with so much working and not brokenness, right? Let's put those phrases into the manual now. We do need the rule-seeded manual, obviously, to show the correct phrases. So Maze Gamer, here we go. So this is going to go span ID equals row phrase, let's call it that, right? And then let me use the clipboard here, and this is the column phrase / span. All right, and then at the end of the rule-seeded code, well, first of all, at the end of the default rules here, I want to set document.getElement by ID of column. Did I call it column phrase or call phrase? I don't remember. Call phrase, apparently. So call phrase inner text. No, you missed out the hyphen, Livio. So the column phrase is help him lost, and the other one is Maze Gamer. Right, and then that should actually be at the end of the default rules, which is here, right? This is, yep, this is where they, yep, this is correct. And then this actually needs to select the correct phrases from this piece of code, which I put here. Don't need that anymore. So let's put that here. Let phrases equals that list. Then we find an index between 0 and the length of that list of phrases. The row phrase becomes that, and then phrases dot remove at becomes splice 1, and then we can set this to the other phrase, which obviously needs a dot length here and a next here. There you go. With that done, let's check that it generates the same phrases. So for rule sheet 47 we have Maze Gamer and Twisty Passages. And let's go to my local, I have too many manuals open here. let's go here, 3dmaze.html, rule seed 47, there you go. Maze Gamer and Twisty Passages. Now let's try 471, I guess. I need assistance, and where's the exit? 471. I need assistance, and where's the exit? Alright, that seems to be working. Okay, now the question is, do I want the rule seed? Yeah, I think I do want to do the same thing with the rule seed. So, let's look at the indicators. This is the actual list of indicators. It's in a weird order, so let's just alphabetize that. There you go, now it's alphabetical. It's our list of... oh yeah, I need to update... First of all, let's update the embellished sheet with the phrases part of the rule seed. And this, and right, this is, yep, this is the corridors thing. Very good. And then here, right, so here we need to change this. Right, so Maze Gamer becomes that. And then here, I guess I'm going to call this row phrase indicators. Yep, that's what I'll do. And same here. Call phrase indicators. And then this span ID thing. This can go here. And span. Okay. So now if I refresh the embellished sheet, which come on, Tim, let's do that. Right, so now it says I need assistance and where's the exit, but of course the list of indicators is wrong. So let's quickly fix that. Where was that code? Inner text equals. There we go. So we want the row phrase indicators. Did I change the other one to call phrase? Yeah, I did. Okay. So I want row phrase indicators to say lit, right? The row phrase, no, the row phrase is unlit, right? Unlit. Okay, and now I need all of these indicators. So I'm just going to do this, split this at commas, filter this by. Yeah, unfortunately, JavaScript doesn't have this intersect, so I'm going to have to do the... Yeah, okay, so if this indicator has a letter in common with the phrase, then we include it. There you go. Okay, so I think I'm going to call this the row phrase. Let row phrase equals that, and just so that it is clear what this actually is, right? And then I'm going to do the same thing here. Column phrase, and then this is the phrase. Let column phrase equal that. Column phrase. So now we want lit column phrase. And now we need to write that function common. Letters 1, letters 2. For let I equals 0, I less than letters 1 dot length, I plus plus. For let j equals 0, j less than letters 2 dot length, j plus plus. If letters 1 of I equals letters 2j, return true, return false. Okay, and now let's see this. Bingo. So where's the exit has an R, another R, another R, another R. I is an exit. Then S in where's. All of these have S's. And that's the R in where's the exit. Right, I need assistance. There we go. That's an A. That's... Ooh. Ah, the C in assistance. Nice. That has an N. That has the A in assistance. SIG has an I. SND has an N. And that's also an N. That seems to work. Okay. Yeah, I think honestly I can't really be bothered to change this to potentially like last or second numeric digit. I think this is I think having different mazes is the main thing. That's the main reason we do rule seed support for a maze-based module, obviously. Okay, I think I'm done. So I'm going to submit this to GitHub, or rather to my copy of GitHub. So let's take a quick look at the. I should probably submit this because this is my sort of cleanup of all the folders. And I forgot to submit all of this. Okay. Well, I guess I'm gonna try and... Okay, so what I'm doing now is I'm cleaning up the mod kit in the original version of the 3D Maze module, because it had an old version of the mod kit. So I want to submit those mod kit updates as a separate change, because it contains the entire test harness and everything. And then I want the rule seed changes to be one change so that you can easily take a look at the... Oh, come on. Let's go back to 3D Maze and recreate those directory junctions. Thank you. KM scripts, that's also part of the... okay, this is being weird. Ah, no, it's not weird at all. That worked perfectly. Okay, that. Okay, everything else is part of the rule seed support. So, I guess I will submit this. Okay, update test harness and mod kit and clean up unused assets. So I want to put that right. I just randomly noticed that my version of the repository is not the default, so I'm going to rename this one here to upstream and then make this one the default so that when I push, I can just push and it'll push to mine. Alright, and this is rule seed support. Now before I submit this, I should also include the rule seeded manual. So let's go to let's go to here, take 3dmaze.html, and then let's also go here. Oh, and it turns out that the HTML wasn't even there. Now the CSS has probably changed in all this time, so I'm gonna copy both of these here, and I guess font also. Right, and then we have the font folder, which, you know, I do want to have special elite in there. Font, special elite, there you go. That's the only font I need. And then inside IMG, let's see, we don't want this. Instead, we want a folder called component. And then inside that, we want 3dmaze.svg. Okay, so that's the manual, and now we're gonna go to Google Chrome. Now, if I regenerate this manual, it will probably, not probably, it will make literally no difference, but you know, I'll just update the manual regardless. So we're gonna go into PDFs, modules, and we're gonna give that the proper name of the manual, of the module. There you go, so that's our PDF done. What else? Okay, I think that's good for now. Oh. Why has this file been deleted? I see. Okay, it's possible that I accidentally submitted the actual, like the... Okay, yeah, I probably did. I accidentally submitted that as part of the update thing. Would you want to bet that that is the case? Yep, indeed. Oh, not just that. I also submitted... No, this is all modkit. There you go. These. I should not have submitted those two files. So, I'm going to do the following. So first of all, do this. Yeah, and obviously that's rule seed support, but I I think that's all I need. So here's what I'm going to do. I'm going to submit this, and then I'm going to use rebase to squash both of those together into a single commit, like this. And then I'm going to reset back to before that change, reset that, mixed, and now all of the changes are back here, which means that now I can, there we go. So now I can pick out exactly what I want to, yeah, that's part of just updating the versions. So shaders, alright, so this is all modkit, this is all cleanup of the examples folder. KTANE scripts is modkit, materials, these are all modkit, these are all modkit, this, bingo. I want to keep these changes. Yeah, this will be part of the KM scripts thing, so I'll keep that change. So all of this revert, and then all of these revert, and that, I guess. Yeah, because I moved all of this to scripts. Yeah, okay. So these are all the shaders. We don't need those. I mean that's part of the modkit. Here's the entire test harness, which has tons and tons of files. And then we have textures. Here's the manual. Right, let's undo that. Not undo, but unstage that. And that's it. Okay, now update test harness modkit and clean up unused assets. There we go. And then implement rule seed support with dynamically generated mazes. Okay, that should be it. Okay, now I should be able to push this. I'm going to push this to my own repo, obviously, and then I'm going to submit a pull request. Okay, now before I submit the pull request, I think I'm going to play this module once, at least once, or maybe a few times. So I'm going to play it with rule seed 471 and see if I can solve it. All right, I'm intentionally not looking at the console now. I know that it contains the floor markings. All right, we have a Bravo and a Charlie, and that's a cardinal. Twisty passages indeed. Look at this. Alright, still only Bravo Charlie. And still only Bravo and Charlie. What is the third letter? It's a hotel. Bravo Charlie Hotel. Okay. Bravo Charlie Hotel. Alright, let's see if this line is informative. It's a blank, then hotel, hotel, blank, blank. That would be this line here. So if we go left forward, and then left forward there's another hotel, which means that that November was a decoy, and south is the correct rules, the correct cardinal. Right, so south. Now we have row equals 5, column equals 6, and we have an unlit micas A and CLR and a lit SND. So let's take a look at this. For unlit, we want to count I need assistance. So I need the C in assistance. So both of those unlits count, which means the row is 7. For the lits, we want, whereas the exit has an S, so lit SND count, so it's 7, 7 south. Let's quickly verify if that is correct. 7, 7 cardinal south is correct. So let's steer from this place to 7, 7 south, which is this wall here. So we want to go left and then, no, we want to turn around actually, and then go up 2, and then left, and then forward 2, and then left. And that is solved. Okay, I think we have it. Alright, now I'm going to close Unity. Ooh, I did not change the oh, of course, I want the rule seed back to 1. Apply that save, and then close, and I bet that that inadvertently made another change to the prefab rather than the scene. I thought it was going to be the scene, but whatever. I'm just going to do this and just rebase that. Just put those together and then push. And now we have a viable KTANE 3D maze. I think this is what I called it. And there we go. This branch is 2 commits ahead. So I'm just going to pull request that. Generate the pull request. Implement rule seed support. I don't need to duplicate that. Okay. And with that, we now have a rule seed support pull request. That was a lot of work. So I had been planning to do something else after 3D Maze. Oh yeah, I was going to do something on Souvenir. But I need a break. I need to eat dinner. So I'm going to postpone that until another time. And besides, nobody is watching anymore anyway, because this has been going on for quite a long time. Dr. already has rule seed support, Livio. That is... No, wait, I'm talking nonsense. It does not. No, it was another... What was it that I added rules? I can't remember. I got confused with Dr. but no. Okay, I guess I could do Dr. at some point in the future. But anyway, so I want to thank everybody for watching. Thank you, another TV viewer, Banana Lord, Commander Root, Dino, Rubix, Livio, lots of S, Mark, Sam, Paul, Sean, and Universe. Loot? Oh, splitting the loot. Yeah, well, splitting the loot doesn't really need it, does it? I mean, the only things that you would change would just be the numbers in the table, and that's not really something that you would memorize anyway. Anyway, thank you everybody for watching, and I hope that you enjoyed the stream. And I will see you again, maybe next time when I do Souvenir, maybe when I do Mouse in the Maze, which is definitely my next plan. So again, thank you for watching, and I will see you another time here on Tim Wee Turby's stream. Goodbye!